All right, guys, good afternoon. If you're online, can you hear me? See the screen? All right, some thumbs up. All right, so we're gonna do some revision work today. So I sent all the topics I wanted to cover based on the feedback from you guys. So persons wanted circuit theory, persons wanted bearings, persons wanted matrices and vectors. So I'm gonna try to see if I can cover all of those topics today. If there have been things that you would have already learned, and all you need to do is just some reinforcement of some of the important things. So I'm going to start out by covering a little quick revision of each of them. The main things that we need to know. It is being recorded, so you can always go back and watch the recording. So I'm just going to touch on the main things that you need to know for each of the topics. And then we're going to spend the time just doing past paper questions. And we're going to be doing the most recent past paper questions. So I want to do like 2025, 2024, 2023, work our way down. Might take a little short break in between as we go, and then we'll come back and we utilize the time and see how much we can cover in the 5-hour period. Maybe we can take 2 breaks in that period. All right. So, in no particular order. Hold on a second. Hold on a second. All right. Sorry about them, guys. All right. So, in no particular order, what we have on the screen is the bearings. I also have this on the screen, circuit theory. So let me start with the circuit theory. Right? And what is seen on the screen here are the main things that we need to know in circuit theory. You have to be able to identify the angles in circuit theory. All right? And it comes with practice. But as we do the questions, I show you the approach that we use to identify the angles. All right? These are like 7 main things we need to know. See? 7 main things. 1, 2, 3, 4, 5, 6, 7. There are other things we need to know. So, for example, rules about parallel lines, like Z angles, when you have parallel lines and a transversal line, Z angles are equal. Co-interior angles, the U angles are to 180 degrees, those things. Total angle of triangle is 180 degrees. 2 angles opposite equal sides of an isosceles triangle are equal. Those things are also valid. But then in addition to those things, we need to know these 7 things and identify these 7 things in circuit theory. And I can just basically maybe touch on each of them. And the first one we spoke about is this one. We call it the center rule. That the angle at the center, angle at the center of a circle here is twice the angle at the circumference. When the 2 angles are subtended by the same arc, in this case, those 2 angles are subtended by this arc, or when they are subtended by the same chord, this chord. So when the 2 angles are subtended by the same arc or by the same chord, the one at the center is twice the one at the circumference. Simple as that. So the one up here, so it's 30 degrees, then inside here, so it's 60 degrees. All right? Angle at center is twice the angle at circumference. That's the first rule. And we can see it right here. Angle at center is twice the angle at circumference. We call that the center rule for short. That's the first one. The second one we dealt with in the class, what we call the diameter rule. And the diameter is a line connecting the circumference like this one, and it must pass through the center for it to be a diameter. A diameter will always subtend an angle of 90 degrees at the circumference. So we call it the diameter rule. Angle subtended by a diameter is 90 degrees at the circumference. Angle subtended by a diameter is 90 degrees. I can say a diameter subtends an angle of 90 degrees at the circumference. All right? So that is it. The third one, we call it the tangent and radius rule, because we're talking about the angle between a tangent, this is a tangent, and this is a radius. At the point of contact, they make 90 degrees. We call it the tangent and radius rule. Angle between a tangent and a radius is 90 degrees. Tangent and radii makes 90 degrees. They meet at 90 degrees. Angle between a tangent and a radius is 90 degrees at the point of contact. All right, so looking out for those. And a tangent is a line that touches the circle at a single point only, right here. It touches at a single point only. Does not look like it touch because we have to draw the tangent with thickness, and we have to also draw the circle with thickness so that we can see them. But theoretically, a line has no thickness and the circle has no thickness. So if the thinner we draw these tangent and the circle, is the more you will see that this is just only one point of contact. One point of contact. We just have to draw them with thickness in order for us to see them. All right, that's the third rule. Then the other one we call the two tangents rule. See, two tangents. That's two tangents from a single external point. Those two tangents. Two tangents from a single external point. So the thing is, only two tangents you can have from a single external point. Only two. You have one on this side and one on the other side. Both of them relate to the circle in exactly the same way. The two tangents and the two radii, the two tangents relate to the circle in the same way. So the two of them have the same length. That's what this means. They are the same length. So the distance from the point out here to the point of contact here is the same for both of them. So this length and this length is the same. So from the point of contact to the circle, the same distance, the first thing. All right. Second thing to note is that the two tangents, these two tangents, this one and this one, together with the two radii, that's this one and this one, they form a cyclic quadrilateral. And that is a cyclic quadrilateral because the opposite angles are supplementary, meaning that they add up to 180 degrees. Remember, this angle has to be 90 degrees because I'm between a tangent and a radius. And also, this angle here has to be 90 degrees as well. And so the total angle between these two so far is 180 degrees. Then these two up here must also add up to 180 degrees. So it's a good thing to know. This angle between the two tangents and angle between the two radii, see here, they add up to 180 degrees. So for example, if the angle between the two tangents up here is 40 degrees, then automatically the angle between the two radii inside here is 140 degrees because they must add up to 180 degrees. That's something good to know. Two tangents and the two radii, they form a cyclic quadrilateral. And CXC will also ask you, for example, why is this red quadrilateral a cyclic quadrilateral? Why is it a cyclic quadrilateral? It's a cyclic quadrilateral because the opposite angles add up to 180 degrees. That's what makes it a cyclic quadrilateral. A quadrilateral is cyclic for one of two reasons. One, if the opposite angles are supplementary, meaning they add to 180 degrees. That's one. A quadrilateral is also cyclic if the four vertices are on the circumference of a circle. So these four vertices are not on any circumference that we can see. But the point is it is possible to draw a circle passing through these four vertices. It is possible. That's why it is also cyclic. But the main reason why this is cyclic, if CXC should ask you, why the two tangents and the two radii is cyclic, because the opposite angles are supplementary. That is the reason. All right? That's a two tangents rule. Then we come to same segment rule. Angles in the same segment are equal when they are subtended by the same arc or subtended by the same chord. So for example, all these angles, all three of them are subtended from these 2 points. They are subtended by this arc. And if you don't want to show the arc, you want to show the chord instead, they are subtended by that chord. Subtending that one, same chord, subtending that one, same chord, for subtending that one. All three of them are in the major segment. Remember, the chord divides a circle into a minor and a major segment. So under here will be the minor segment. This will be the minor segment. And everything over here would be the major segment. All three angles are in the same segment. They're all in the major segment, and they are all subtended by this chord. And so they are equal. Angles in the same segment, subtended by the same chord, or subtended by the same arc, because I can move the chord, and so that they are subtended by this arc. They are all equal. Angles in the same segment are equal when they are subtended by the same arc or subtended by the same chord. All right? So that's that rule. Same segment rule. We call it the same segment rule. That's what we call it, same segment rule. Then we have the cyclic quadrilateral rule. So a cyclic quadrilateral is one where 4 vertices are on the circumference of a circle, or it can be that the opposite angles are supplementary. But this is the one now where they give you a circle and they give you a quadrilateral in the circle, and the 4 vertices are on the circumference. 1, 2, 3, 4. All 4 vertices are on the circumference of that circle. Once we have that, it is cyclic. And if it is cyclic, the opposite angles, these two angles add up to 180 degrees, and these two angles opposite each other add up to 180 degrees. And the key thing when writing the cyclic quadrilateral rule, you have to put the word opposite in the rule. A lot of people have the tendency of just saying angles in a cyclic quadrilateral add up to 180 degrees. No, you have to say the opposite angles in a cyclic quadrilateral add up to 180 degrees. All right, so here is sum 180 degrees. And another word for saying this sum 180 degrees is to say that they are supplementary. Supplementary. That's a mathematical term for when angles are to 180 degrees. All right, so that's a cyclic quadrilateral rule. All right, so much we got. Gone 6. Then we have the last one. The last one is one that tends to give people problems sometimes. I don't know why. All right? The last one is one that tends to give people problems, but you don't need to be giving it the problem, because you need to be able to look out for it. And it is that the angle between a tangent and a chord, the angle between the tangent and a chord. So for example, this tangent out here, I'm marking out in red, and this chord up here. The angle between that tangent and that chord right now is this angle x out here. So rule says, since the angle between the tangent and the chord is x, then the chord itself is going to go and subtend the same angle x at the circumference. So that chord will go now and subtend that same angle x at the circumference here, which is what it did. So the angle between the tangent and the chord out here is equal to the angle subtended by the chord in there. And it goes both ways. So if you know this angle, then you can know the one out here. And if you know this angle, then you automatically know the one in there. Because the angle between a tangent and a chord is equal to the angle subtended by the chord at the circumference in the alternate segment. So it's like this angle is in this segment, and the angle that it forms at the circumference is in the alternate segment over there. So some people call it it's called alternate segment theorem or alternate segment rule. But we just call it the tangent and chord rule, because we're talking about the angle between a tangent and a chord. So the angle between a tangent and a chord is equal to the angle subtended by the chord at the circumference in the alternate segment of a circle. Very good rule to know. And it works on the other side of the tangent as well, over here. So if you look at the other side of the tangent over here, the angle between this tangent on this side and this chord up here, angle between them is this angle y. So because the angle between the tangent and that chord is y, then the chord itself will go and subtend that same angle y. Will go and subtend that same angle y up here. The chord is going to go and subtend the same angle at the circumference up here. So this angle y in here is equal to this angle between up here. Angle between a tangent and a chord is equal to the angle subtended by the chord. All right? So that's a quick revision of the rules. We're going to do some questions, as I said. And what I'm going to do, I'm just going to pick up past paper and we're going to do any of the topics that's on that past paper. It's going to start with 2025. Last year, 2025, do an exam. And if circuit theory is there, we'll do it. If bearings is there, we'll do it. If matrices is there, we'll do it. If vectors is there, we'll do it. So we're not going to do one topic at a time. We're just going to do a paper at a time. If things recorded, you can always play by the recording as you like. So that's a quick revision of circuit theory. So persons at home, if you don't have this, I would suggest you screenshot it and keep it. All right? You have it in the group already. This document is in the group. This document was sent in the group. All right? So let's go now to the revision for bearings. The thing that you must know for bearings. So this is a little diagram of things you must know for bearings. Again, I would advise you to screenshot it. If you're at home, you guys would have this again in the group already. If you don't have it, I can always send it to the group. All right. So one main thing to note about bearings, guys. Bearings in simple terms is just a way of expressing a direction to somewhere from one place to another place. That's what it is. And it is direction horizontally on the ground we're talking about. All right? So it's like bearing is like looking around. But the rule is that it's like you have to face north first, you have to look to the north first. And then it is the angle through which you have to turn to the right to look to get the bearing of the direction that you want. So they say it's the clockwise angle from the north direction to the direction that you want the bearing in. So bearing really is a direction. All right? And it's measured clockwise at the from position because you want the bearing from somewhere to another place. Bearing is a direction, is a way of expressing a direction from one place to another place. All right? And it's not even from one place to another place, just a direction, generally speaking. Because the direction is constant. The direction remains constant at every point in the same direction. Let me explain what I mean. I'll explain it a bit further. So, for example, in this first one, this first example here, you want the bearing from this place to this place, which is the direction. So it's like you want to know what this direction is. You want to know what the direction up here is. You want to know what that direction is. Let me zoom in. So like you want to know this direction. You want to know what this direction is. That way. You can give that direction as a bearing. And the bearing now is a clockwise angle from the north direction to this direction. So to the north direction here. Now, a lot of people think this is pointing to the sky. No, it's not pointing to the sky. It's pointing horizontally. East, west, north, and south are horizontal directions on the surface of the earth. So this is like you're up in the sky looking down on the ground. Right? This diagram is like you're up in the sky looking down at points on the ground. And this is the direction towards the north. Right? So if you're in Kingston, north is to the mountains. If you're in Kingston, the north is towards the mountains. If you face the mountains, you're facing north. Right? If you face St. Thomas, you're facing east. If you're in Kingston and you face the sea, you face the sea, then you're facing south. If you're in Kingston and you face like Montego Bay side, towards Montego Bay, and you face Spanish Town, then you're facing west. All those directions have a bearing. So the bearing of east is 090 degrees because if you face north first, you have to turn 90 degrees to the right to face east. The bearing of south is 180 degrees, because if you face north first, you have to turn to the right 180 degrees to face south, to see the direction to south. And then the bearing of west is 270 degrees, because if you face north first, and you want to face west, and you want to go in the direction of west, you have to turn to the right 270 degrees in order to face west. So the bearing of west is 270 degrees. Now, an important point to note again with bearing is that it must be given in 3 digits. So that's the angle 75 degrees, but the bearing is 0.75 degrees. So you must always give 3 digits for your bearing. If you're doing a question, for example, you get 261.4 degrees for your bearing, for your calculation. You just put 261, round it off to the nearest 3 digits, 261 degrees. All right? Because in real terms, the 0.4 not going to make a big difference. But this is about direction of places on the surface of the earth, you know. So like, what is the bearing from Kingston to Montego Bay? The 0.4 is not going to make a big difference. Because Montego Bay is not just a point, it's not a spot. Montego Bay is a big place. What's the bearing from Jamaica to America, or from Kingston to Miami then? Miami is not a spot. It's a big place. So the 0.4 don't make any big difference. So that's why it's okay to just give 3 digits. You run it after the nearest whole number, 3 digits. All right? Right. So back to this. So it's like the bearing on this diagram is that we want to know what this direction is in terms of a bearing. So you want to know what the clockwise angle would be from the north direction. That's why we put in the north direction here. So you put in the north direction, and then you want the clockwise angle to this direction that you're measuring here. All right? And that's the same direction. So if I come up at this point, no, if I come up at this point, and I extend this direction further, and I extend this direction further this way, that is the same direction. Right? So if I measure the bearing at this point, then I put a north line at that point, same way. It's the same direction that is. So the bearing of that is still 0.75 degrees. The direction has not changed. So anywhere on this line I am on, the bearing of that direction will always be 0.75 degrees. Even if I come back to a point before this one, let me put it in blue. If I come back to a point before this one, it is the same direction. So the bearing from this point is still 0.75 degrees, because bearing is a direction given as an angle clockwise from the direction. All right? Let's continue with these. We're going to put all of this together in questions. All right? And I'm going to say some other stuff as well about bearings questions. But let me just go through this first. And say a couple of things. Over here, so you notice, must always express in 3 digits. So if it's 4 degrees, I put 004 in it, right? Must always be expressed in 3 digits. Well, this is showing you that the north lines are parallel. Because the north lines are parallel, you have a situation where you create alternate angles, right? So if I extend this line down here, then I form a Z angle. So this angle is the same as this one, 75 degrees, because the north lines are parallel. The north lines are parallel. So a common thing that is produced in this situation is this one. So you're talking about the co-interior angles. So these two angles here, these two angles add up to 180 degrees. They are co-interior angles. That's what we are showing right here. These two angles, right? Because of the parallel line, these two parallel lines connected by this one. So a common thing in bearings question is to get these two angles. So if you know this one is 75, then this was 105. Because it must add up to 180 degrees. All right? And then we also, as I spoke to you about, we also have the alternate angle. So again, if this angle is 75, I extend this north line down, then this angle is 75 as well, because of the Z angle. So the Z angle there which we call alternate angle. So that's again another popular angle to know. And then after I get this angle right here, 105, right, from this situation, then a common thing to do is to know that total angle around here now becomes 255 because the total angle around this point is 360. So this angle here, this green angle becomes 360 minus the 105. Again, that's another popular calculation, right? And we can see it on the screen, right? Because this angle plus the green angle over here, it must add up to 360. Because total angle around the point is 360. That's another popular calculation. All right, that we are seeing here. All right, for this diagram down here, notice even though we want the bearing to this direction, it cannot turn left. No, you cannot turn left. You still want a clockwise angle all the way around here. It should be 210 degrees. You always want to angle clockwise at the front position, clockwise from the north line at the front position. All right. So these are some of the common things. So let me show you now. If you wanted to reverse the bearing, I'm sure you can maybe reverse the bearing. So let's say we have this diagram here. All right, and I want the bearing of this direction instead, the opposite way. All right, I want the bearing of that direction, the opposite way. Then I need the north line up here. And to get the bearing of this direction the other way, I would want this angle around here. That's the angle I would want. But remember, it's not difficult because remember now that if you extend this line and keep the direction, this direction is still 75 degrees, 0.75 degrees. So this angle up to here, so it's still 75 degrees. Right? And then on the red line between here and here is 180, because total angle on straight line is 180. So the red line from here to here is 180 degrees. The red angle from here to here is 180 degrees. That's 180 degrees. And the piece inside here is 75 degrees. So the bearing angle all the way around here, the bearing of this direction back down here is all of this angle here. Total angle around here, which would now be the 75 plus the 180. So that's a good way of reversing the bearing direction and the bearing of the reverse direction. That purple angle will be 180 degrees plus 75 degrees. So it's a good way of getting the bearing angle in the opposite direction. All right, we're going to see that in some questions as well as we go. All right, so you can play over the video and watch how this is done again. But we'll see it come all together in a couple questions. One key thing to note though with bearings is that bearings really is the application topic in CSEC for the use of sine rule and cosine rule in triangles that are not right angle triangles. That's the main purpose of giving you this topic in CSEC, because I want to give you a real life situation where you have to use sine rule and cosine rule. And the sine rule and the cosine rule are used in triangles that are not right angle triangles, where you can't use Pythagoras' theorem because the triangle is not a right angle triangle. And you also cannot use so-called term. Sine equal opposite over hypotenuse, cos equal adjacent over hypotenuse, tan equal opposite over adjacent. You cannot use those if the triangle is not a right angle triangle. So bearings is a topic that will always produce triangles that are not right angle triangles, and you have to use sine rule or cosine rule. Most of the time, the questions are set up to force you to use the two rules. And to ensure that you use the two rules, they tend to set the question, so you have to use the cosine rule first. Right? You have to use the cosine rule first. And then after the cosine rule, there's another part of the question where you're using the sine rule to finish that. We're going to see some examples. All right? And I remind you of when you use the sine rule and when you use the cosine rule. Generally speaking, you use the sine rule when you have a triangle where you know the angle and the side opposite each other. And you know the values. So for example, if I were to just sketch a triangle right now, a random triangle, let's say that is your bearing triangle. And let's say you know this angle. So this angle is 40 degrees. And you know this side is 20 kilometers. 20 kilometers. Then once you have these two that you know them, you can use sine rule, because that's what you need to use the sine rule. An angle and a side opposite each other, where you know both of them. So any other piece of information you know now, you can find anything else. So for example, if I also know this side, so this side is 15 kilometers, then I'm able to find this angle using the sine rule. But I'm pairing these two on one ratio on the sine rule, and I'm pairing these two the other ratio on the sine rule. So I would say something like the sine of theta over the side opposite to the theta, which is 15, becomes equal to the sine of the angle that we know, which is the 40 degrees, over the side opposite the 40 degrees, which is the 20. That's how you start. And then you try to find the theta. So you're going to transpose to find the theta. So you transpose this to find the theta. I take the 15 first, I multiply it up here. So then you would have the sine of theta equals 15 times the sine of 40 degrees divided by 20. And then to find the theta now, to find the theta, you're going to take the inverse sign, bring the inverse sign in front of this. So the theta then becomes sine to the minus 1 of the 15 sine of 40 degrees divided by 20. You roll this out to the calculator and you have the angle theta. Simple as that. All right? I have other situations now where could have been that instead you know this angle. You know this angle, for example, this angle might be, so this angle is 31 degrees. I know it, you know, trying to find this side. Right? So in that case, it would be you put this side over sine of this angle. Right? Start with what you want to find first. I would put x over the sine of 31 degrees equals the side that you know now, the 20, over the sine of the 40 opposite to it. And then take this now, you multiply it across, you have the x. So in this case, the x would be equal to, multiply it over here, it becomes 20 times the sine of 31. Must always put the trigs, behind the multiplier. All right, always set it out that way, divided by the sine of 40 degrees. Work this out and you'll have the x, if that is the case. Now, if in the triangle, you don't have an angle and a side opposite each other, right? That you know both of them, as we did here, then you have to use the cosine rule. That's simple as that. Right? Once you don't have a pair of angle and side opposite each other, we know both of them, they don't have any chance. You have to use the cosine rule. So for example, if I did not know this, if this is what I had, so that was 31, and let's say this side was 20 kilometers, and this side was, say 31 kilometers, or 30, so 30, 30, 37 kilometers. Then that's the use for the cosine rule. But the one angle that I have, I don't know the side opposite to it. All right? And so I would have to use cosine rule to find the side opposite this angle over here for calling it x. Remember now that cosine rule starts out like Pythagoras' theorem. Cosine rule really is a derivative of, or Pythagoras' theorem could be seen as a derivative of cosine rule. So you start out that if this was an hypotenuse and this was a 90 degrees, just start out that way. So you don't have to write on a formula. So Pythagoras' theorem, if this was an hypotenuse, it would have been that x squared is equal to this side squared plus that side squared. It should be 37 squared plus 20 squared. That's how it would start out if it was a right angle triangle, but it's not a right angle triangle. So if you subtract that, subtract the piece, if you subtract 2 times the product of these two sides without the square, 37 and the 20, and then you cosine the angle between them, which is 31 degrees. And for this calculation, this can be placed in the calculator straight. But what we can also do, instead of leaving the square on here, we can cut the square of this with a square root and square root this side instead. And just get the x straight. So we can do that as well. So a lot of the times you have to do this in bearings question. You have to use the sine, you have to use the cosine rule. Normally, you have to do this first. Cosine rule first. And then, second part, you have to find an angle with the sine rule. Right? All right. We're going to see questions here. That's what we're going to be. All right. So that is bearings. So we thought circle theory, we thought bearing. Let's touch on matrices now. Quick. The main things to remember in matrices, right here. The main things to remember in matrices are on the screen. I'm going to share it down like this so that you can screenshot it. And students in this group, this class would have had this already. These are the main things to remember in matrices. People online who can screenshot it should be seeing it clear. But let me zoom in now. Main things to remember in matrices. All right, let's zoom in. So, firstly, we are required to find determinants of 2 by 2 matrices. And this is how it is done. It is the first diagonal product, the A times B, minus the second diagonal product, B times C. That's how we calculate the determinant. And you can say the determinant is the value that determines if the matrix has an inverse or not. Because if the determinant is 0, then the matrix has no inverse and is said to be singular. So a singular matrix is one that has no inverse because the determinant is equal to 0. The determinant is not 0, then it has an inverse. So you could say the determinant determines if the matrix has an inverse or not. But that's how the determinant is calculated. And sometimes the determinant of a matrix is expressed like this, with the modulus symbols around it. All right? Sometimes it is expressed like that. What else? The inverse of a matrix. Inverse of a matrix is written m to the minus 1. So if the matrix over here is m, then how do we get the inverse? The inverse of the matrix is 1 over the determinant that we just calculated here, multiplied by this thing that we call the adjoint matrix. We call that the adjoint. This matrix is called the adjoint. How do we get the adjoint? Let me write out the matrix M here so we can just show you quick. So M was the matrix A, B, C, D. Right? So the determinant is coming under here, as you can see, which is this product, the first diagonal product. Some people teachers call it the leading diagonal, or the first diagonal, or the main diagonal. This diagonal up here, these two values. The product of them, that's the A times D, minus this second diagonal product is the BC. That is what gives the determinant that comes under here. Then this thing inside here is called the adjoint. How we get it? How we get the adjoint? You interchange these two elements on the first diagonal. The first two elements on the first diagonal, you interchange them. So you have AD this way, it becomes AD the other way. You switch them around. So the AD on the main diagonal become DA down here. See, they are switched around. And then the other two elements, they are not switched around. They remain where they are, but they change sign. Those two elements on the second diagonal, they remain where they are, and they change sign. And that's how we calculate the inverse matrix. 1 over the determinant multiplied by the adjoint. And I just show you how the adjoint is formed. We're going to do it with some numbers later. All right? Then here, this line, the next thing we must know is about singular matrix. CSEC like to ask questions about singular matrix. And sometimes instead of telling you that the matrix is singular, they might actually tell you that it has no inverse. So remember, if they tell that the matrix has no inverse, it means the same that it is singular. And it also means this as well. So those three things those three things go together. Singular matrix means that the matrix has no inverse and the determinant is 0. We normally use this one for the purpose of the calculation, but this is information, these two. So any one of those three things mean the other one. Any one means the other two. So if it's singular, it has no inverse, the determinant is 0. If it has no inverse, it means that it's singular, the determinant is 0. If the determinant is 0, it means that it is singular and it has no inverse. So any one of these three things means the other two. All right? And here, if the matrix is singular, the determinant is 0. So if a question asks you to state to determine if a matrix has an inverse or not, you need to calculate the determinant. A determinant is 0. If it's singular, it has no inverse. If it is non-singular, it means that the determinant is not 0. It has an inverse. All right? All right? And that's what happens. Also, when it's singular, the product of the diagonals is equal. Another thing you can pick up as well. The two diagonal products equal. All right? So when it's singular, this diagonal product is equal to this diagonal product. Because remember, to get the determinant, you have to subtract it, right? So if they're equal, it means that it is singular. So again, you can also use that. All right? Down here, identity matrix for multiplication of matrices. That's what this is. This matrix you're expected to know it. CSEC will give you a question, and instead of writing out this matrix for you, they will just give you the letter I. And you're expected to know that I is for this matrix, 1, 0, 0, 1. That's a matrix that behaves in a similar way that number 1 does in real maths, in regular maths. Right? That's called the identity matrix for multiplication. See it here? The identity matrix times a matrix is equal to the matrix. Or a matrix times the identity matrix is still equal to the matrix. Why is that? Because remember, this is behaving like a 1. It's like I saying 1 times m equals m. Or m times 1 equals m. So the identity matrix behaves similar to the number 1. All right? That's it. So the identity matrix times a matrix, we're going to give about the same matrix. All right? I'm just touching back some of the things that you all need to know. And then one important thing to know as well is that the product of a matrix and its inverse is equal to the identity matrix. The product of a matrix and its inverse will always be equal to the identity matrix. You're expected to know that. CSEC will give you a question to test your knowledge of that. The matrix times its inverse or the inverse times the matrix will always be equal to the identity matrix. Cool? All right. Then we come to addition and subtraction. So matrices can only be added or subtracted if they are of the same size or order. Size or order of a matrix is the number of rows by the number of columns. We're going to talk about that. So for example, these two can be added because they have both same size, 2 by 2 matrices. I just add the corresponding values. So this is not complicated. I add these 2 values to get this one. And you add these 2 values to get this one. Simple. Same thing of a subtraction. If I'm subtracting them, then this one minus this one give you that. And then this one minus this one, for example, give you that. So you just subtract the corresponding values. That's it. So this is easy. Then multiplication by a scalar, multiplication of matrices by a scalar, by a value. So for example, if this is a 2, you multiply each value in the matrix by the 2. Simple as that. Multiply each value by the 2. So if this was a 2, it would be 2a, 2k, 2c, 2d. If that was a 2. So you multiply a matrix by a scalar value, you multiply each element by a scalar value. Right? Same thing, if you multiply it by 1 over k, you multiply each value by 1 over k. Or it is like you're dividing each value by k. Right? So this times this, give me that. And this times this, give me that. And so on. Right? But when it comes to multiplying matrices now, there are some additional things we need to know. Multiplying a matrix by another matrix. Let's go down to some of the nitty-gritty that CSEC expects us to know and will test and all the time down in here. So I wrote it out for you already. So firstly, they will ask you, when is the multiplication of matrices possible? Or the word I use for when it is possible is when they are conformable. When the matrices are conformable to the multiplication. When are they conformable? Sorry. When are they conformable to multiplication? They are conformable when the number of columns in the first matrix is equal to the number of rows in the second matrix. When the number of columns in the first matrix is equal to the number of rows in the second matrix. That's when it is said to be conformable and the multiplication is possible. When the number of columns in the first matrix equals the number of rows in the second matrix. So for example, So for multiplying two matrices, A times B. And the A is a 3 by 2 matrix, a 3 by 2 matrix, meaning A has 3 rows and 2 columns. The first value is the number of rows. The second value is the number of columns. That's how we express a matrix, or the size or order of a matrix. So this example is like we're multiplying a 3 by 2 matrix. So for to sketch it out, 3 rows, 2 columns. So 3 rows of values and 2 columns of values. See that? 3 rows, 2 columns. That is my matrix A. Let that be my matrix A. And I'm multiplying a matrix B. But B knows that 2 by 4, meaning 2 rows, 4 columns. 2 rows only, but 4 columns. See? 2 rows, 4 columns. 1, 2, 3, 4. Now it is possible to multiply these two matrices. Why? Because of this. The number of columns in the first matrix is 2. See it here? The number of columns in the first matrix is 2. And the number of rows in the second matrix is also 2. Them two values are equal. That's why the multiplication is possible. And the resulting matrix will take the number of rows from the first by the number of columns in the second. So the answer becomes a 3 by 4. See, a 3 by 4. So the resulting matrix will take the same number of rows that's in the first matrix, and it will have the same number of rows that's in the first matrix and the same number of columns that is in the second matrix. So if I were to write what this final matrix would look like, the product AC, to be a 3 by 4. 3 rows, 4 columns. That's what the final matrix would look like. 3 rows, 4 columns. That's what these two products, these two would give us. Yeah. Another thing we must know about matrices multiplication is this, that it is non-commutative. Generally speaking, matrices multiplication is non-commutative, meaning A times B is not equal to B times A. This means non-commutative, non-commutative. I think sometimes I spell it with 2 M's, but don't worry about that now. I want to see it in the question. So matrices multiplication is non-commutative. When you reverse the order of multiplication, the result will be different or it will not be possible. So for example, these two, if I were to reverse them now and try to do a B times A, means that I'll be trying to do a 2 by 4. I'll be trying to do a 2 by 4. I remember the B is a 2 by 4 times a 3 by 2. So remember the A is a 3 by 2. See here now, these two numbers, the number of columns here, the number of rows there, they are not equal. Therefore, this multiplication is not possible. Not possible. Cannot be done. And that's another proof that it is non-commutative. Sometimes we reverse the order, it's not possible. Other times we reverse the order, it is possible. The result will be different. The only time the result is going to be the same is when you're using the I matrix or a multiple of the I matrix. When you reverse the order, the result it can't be done. But generally speaking, matrices multiplication is non-commutative, meaning when you reverse the order, result is not the same. CSEC like to test this. So they like to test your knowledge of the non-commutative nature of multiplication of matrices, and they also like to test conformable. When matrices multiplication is conformable. What makes them conformable? So the number of columns in the first matrix must equal the number of rows in the second matrix. They like to test that as well. We're going to see that in question. And then how do we multiply the matrices? And now I'm going to put a line across the first one to remind me that we have to use the 2 rows of the first matrix, or the rows of the first matrix. And I put a line down the second matrix, or down the column, between the columns of the second matrix. Remind us that we use the columns of the second matrix to do the multiplication. All right, we're going to do some exercise and show how you create the values on this. All right, so if I want the first value here, for example, because that first value is positioned in the first row and the first column, it means that to get it, I have to multiply this first row by this first column. And how do you multiply a row by a column? Let's zoom in. To multiply this row, let me just put an arrow on them. To multiply this row by this column, I do the multiplication by multiplying the first element in the row by the first element in the column, plus second element in the row by the second element in the column. So it will be first element times first element plus second element times second element. That's how you multiply them. All right? And that's how we'll get this first value here. If you wanted this value out here, or you know which column to use. If you want this value out here, because it is positioned in the first row and the second column, to get it, you have to multiply this first row by this second column and multiply them the same way. You multiply using this row and this column now. So you multiply them the same way. First element in the row by the first element in the column, plus second element in the row by the second element in the column. That's how you multiply matrices. We're going to do some questions and see all of that. All right? We're going to do some questions and see that. Then, let me move this out of the way. They like to give you matrices equations to solve. Most times it is of this form, where this is the unknown that you're trying to find in that position. So these are 3 matrices that are matrices equations. A matrices equation, 3 matrices. Those 2 multiply to give you this. And what it is that you know this one and you know this one. And this is the unknown one. A lot of the time that is the unknown one. And simple matrices transposition that the inverse of the M comes in front of this side. A simple matrices transposition. What happens in the background? I'm going to show you one time what happens in the background, right? Just in case. So, because sometimes CSEC forces you to show what happens in the background. So, like I have a product, MX. MX equals B. Right? Now, if MX equals B, I can decide to multiply both sides by M to the minus 1, but multiplication is non-commutative. So if I multiply the right side in front by the inverse, M to the minus 1, you have to multiply the left side, sorry, you have to multiply the right side in front also by M to the minus 1. Same way. Now what happens is that this M times M to the minus 1 is I, the I matrix, which is the I matrix, which is just at the number 1. So this becomes I times X equals, and this remains M to the minus 1 times B. And then the I times X, remember the I is just like 1, the I matrix, that becomes X equals M to the minus 1 times B. That is what I did in red, is what is happening in the background of this transposition. But simply put, the inverse of M comes in front of the B. And when you finish doing this calculation, it equals X. Now, on the syllabus, right, I've never seen them set a matrices question for this solution where the unknown is not in this position. But let me show you still just in case. Because it could be that the unknown is in front. Right? So suppose instead the matrix was like this. That I give you. X times M equals B. Suppose the unknown is in front. Whatever reason. Right? When you transpose away the M, because the M appears second on the left side, you have to put the M to the minus 1 second on the right side as well. So this one You would have to transpose it and put m equals b times x to the minus 1. Very important. No, sorry. Sorry. I'm trying to find the x. My mistake. I'm trying to find the x. It's the x I'm trying to find. Right. So the x will be equal to b times m to the minus 1. So because the m was second on that side, the m to the minus 1 must go second on the other side. Remember, that is important because matrix multiplication is non-commutative. So that is important. Right? So look again carefully, guys. As I said, I've not seen CSEC set any like this, where the unknown is in front. The unknown is always in the second position here, almost every time. So everybody knows that the inverse must go in front of the right side because the m was on the front and the left side. If the unknown is in front, such that you have to transpose away the m, or the m is second on the right side, then the inverse must go second on the right side. If the unknown is second on the left side, the inverse must go second on the right side, if they ever set it. And the funny thing about it is that even though they have never set one like this on an exam paper, they put it on the specimen paper. So this is on their specimen paper, but they don't set none in an exam yet. So because it's on the specimen paper, it means that it is possible that it can come on an exam. All right. So when they set this one, it's like you have a 2 by 2 times a 2 by 2 equals another 2 by 2. And you are trying to find this answer as a 2 by 2. That's what you have to do. All right. So that is it. Matrices format is like this. This is most times that's what you get to solve. All right. So if you have this time, this equal, this is not what I call this. It's not actually equal to a column vector. Can't equal this. So that's a mistake. Can't equal a 2 by 2. That would be equal a 2 by 1. So really should be like that. EQ. And then be like that. EQ. So the inverse of this comes in front. All right? See there, the inverse of this comes in front. But again, we're going to see some numbers with this. We're going to see some numbers with this. And this now is typical of what they like to give, simultaneous equations, guys. They like to give simultaneous equations sometimes. Use a matrices method to solve. First, you have to convert it to a matrices equation. Ensure that two equations have the x value followed by the y value, both of them x followed by y, and then it becomes an equation like that. So it's always a column vector, xy there, equals a column vector with these two values over here. Then it's the coefficients of the x and the y that populates that 2 by 2 matrix. All right? So the A and the B, A and the B, and the B, C and the D, C and the D. When doing this though, guys, you have to be careful with the signs. So if this was a negative B, you put a negative B there. So. And if the A was there, for example, if the A was there, if there was no A here, then this coefficient will be 1. That is just 1x. If there's no x, if there's no number in front of x. You understand? Good? All right. Hopefully we'll get some questions. So that basically summarizes. Oh, and then from this now, as I said, from this equation, the inverse of this will come in front, which is what I have here. And you work this out, whatever value you get for this. When you finish work this out, you're going to get a column vector. Like suppose you get 3, 7. It means that the x equals 3 and the y equals 7. People tend not to write this. You have to remember to write that. Because the question is for you to find x and y. So after you finish work out this question, this calculation, you get that. And generally speaking, when you're doing this calculation, right, do the matrices multiplication first. Do that first. And leave the fraction out here for last. All right? We'll start the questions and repeat that. All right. So the only thing left to touch on now quickly is vectors. Important things to remember in vectors. I think I have something here, the vectors as well. Where is it? These are some of the most known things for vectors. Again, students in this class would have gotten it in the group. If you don't have it, you can ask me, I'll send it again. But that's some of the important things. All right. I think maybe some of this will come out a lot better when start with the steps, right? But some of the important things. Midpoint. Portion vector of a midpoint. But you don't necessarily need portion vector of the midpoint. So let me not spend any time on that. We can do the question without that. But generally speaking, the portion vector of the midpoint is the average of the portion vector of the endpoints of a line. So if you want the portion vector of the midpoint of a line AB, if you want the portion vector of the midpoint of the point of the line PQ, P and Q. Oh, this one is displacement vector. All right. This one is displacement vector. All right, so let's go. So these are called position vectors, right? Because it's from the origin to the point, from the origin to the point. So this is the portion vector of P. And CSEC will ask that, what is this called? I've seen them ask it. It's called a portion vector of P. And this one is a portion vector of Q. This one is a portion vector of Q. And generally speaking, position vectors and coordinates have the same values. So the portion vector of P is 2, 3. It means that the point P will have the same value as 2, 3. And the portion vector of Q is minus 6, 5. It means that Q on a graph would have the same values, minus 6, 5. So sometimes they give it a point and ask for the portion vector, but really they give the portion vector and ask for the point. We have to know that. Then now, if you know the portion vectors, I want to find this that we call a displacement vector. The vector from P to Q is called a displacement vector. Then a simple way to find it is O times the last, which is the OQ, minus O times the first, which is the OP. So we'll call it last minus first. We want to find PQ is O times the last minus O times the first. So the portion vector of the last, where Q is the last, minus portion vector of the first, P is the first. A nice quick way to calculate displacement vectors, where you know the portion vectors. All right? If you want the midpoint, portion vector of the midpoint says M, then let me use a different color. The midpoint would be OM, like an average point, to be half of the OP plus the OQ. Like you're averaging the two portion vectors to get the midpoint. All right? If you want the portion vector of the midpoint of PQ, you just average the two portion vectors. Just like with the coordinates. You average the coordinates, you don't want to find the midpoint of a point, right? You average X coordinates and average the Y coordinates. Midpoint is like an average point. You're averaging the values in a sense, right? Simple as that. We're going to do some questions and see. Here, you will get something about parallelism. Almost certain to get something about parallelism, parallel vectors, and also or collinear points. But if you're doing collinear points, you still have to go through parallel vectors as well. Key thing for parallel vectors is that one is a multiple of the next. When two vectors are parallel, one can be expressed as a multiple of the next. All right, we did go through some steps of how you do it. And I'm just remind you, it's a 3 steps process that we use in this class. All right, so let's say we want to show that these two vectors are parallel right now. Our first step is to get rid of any fractions. That's what we said. Because you want to be able to show that Mn is equal to some multiple of Rs or vice versa. That's what you want. From these two vectors to show that they are parallel, you need to get something like Mn equals some number, call it K, times Rs. K is some number that you need to figure out. To do that, we use a 3 steps process in this class. The first step is to get rid of fractions. Get rid of fractions. Why do we get rid of fractions? Because a lot of the time, fractions make it more difficult to see the relationship between the vectors. Right? So you get rid of fractions. So you can see better the relationship between them. So to get rid of fractions out of this one, you multiply by the lowest common multiple of the denominator. The lowest common multiple of the denominator right now of 2 and 4 is 4. So I would multiply this vector by 4 as a first step to get rid of fractions. So I multiply this one by 4 to get rid of fractions. Then I multiply the mn by 4, I will get 4mn equal, multiply this by 4, it becomes 2u. Multiply this by 4, it becomes plus 3v. To get rid of fractions of this one, I need to multiply by the 3. So this one, I will multiply this one by 3 to get rid of fractions. So multiply the 3r by 3 first, it becomes 3rs, the rs. Multiply this fraction by 3, cancel the 3, and it gives me 2u. Multiply this by 3, I get 3v. Now these are already equal. See? This and this are the same. Because that and that are the same, it means that this and this are the same. I can equate those two. If they were not equal, I'll go to a step 2, which is to multiply the small one by a number to make it equal the large one. Multiply up the small one, make it equal the large one. That's the second step. If they were not equal, it's just that this example, they are already equal after I get rid of the fractions. But if they were not equal, I would multiply up the smaller vector to make it equal the larger one. And then step 3, when they become equal as they are now, in this example, we equate the vectors, equate them. So here now we're ready to equate because the two of them equal the same thing. So if we're equating on this example on the screen, then we would write 4mn equals 3rs. 4mn equals 3rs. 3rs. And that would mean that they are parallel. Because one of them is a multiple of the next one. Because if I want, I can take this 4 and divide it under here. I can do that. I get mn equals 3 over 4 rs. Or I can take the 3 and divide it under here. I get rs equals 4 over 3 mn. But leaving it like this is also good. This means that they are parallel. Because one vector equals a multiple of the next one. Once you get that, it means that they are parallel. They are parallel. Mn is parallel. This means parallel to rs. Because one is a multiple of the next. All right? The next thing we can ask about is collinear points in vectors to show that points are collinear. When points are collinear, you're going to get parallel vectors with a common point. You're going to have two vectors that are parallel, but there'll also be a common point on them. So the same way I would always show that these vectors appear parallel, you do the same thing down here. So. But then in addition to being parallel, there's a common point. There's a point on the two vectors, which then would mean that the points involved are collinear. That's only 3 points. So for example, here we have PQ and we have QR. So the common point is going to be Q. You have to show us the PQ parallel to QR. And the Q is the common point. You go through the same steps. Get rid of fractions first. To get rid of fractions of this one multiply by 4, it will become 4PQ equals 3A minus B. To get rid of fraction out of this one, I multiply by 3. So multiply the second one by 3 to get rid of the fraction. To get rid of the fraction here, multiply by 3. So multiply that one by 3, you get 3QR. See? 3 times this is 3QR. 3 times that is 6A. 3 times this is minus B. Something around. Oh, this was a 3A. Oh, so them two are nothing like that. But that's 6. Oh, sorry, make a mistake. Multiply it by 4, this becomes 6. My mistake. It becomes 6. It becomes 6. Multiply this one by 4, it becomes 6. Because 3 into that was 2 times 3 is 6. Good. All right. And then multiply this one by 3, it becomes the same thing. 6A minus B. Again, 6A minus B, 6A minus B, them equal. It means that this equal this and this equal. What do that mean here now? Because those two equal. Shift these over a bit. Those two equal. Then I would equate. So when I equate them, I will get 4PQ equals 3QR. 4PQ equals 3QR. That means that they are parallel, because one is a mode of the next, so they are parallel. And there's also a common point Q, which would then mean that they are collinear. All right, so in a nutshell, that's what you're gonna need. That's what you will need to do in vectors. One thing I want to say before we come off these vectors is that if you're doing a vectors question, in particular with the diagram one, and I like to give vectors questions with diagram. Most times, nowadays, when I give a vectors question, it is accompanied with a diagram, comes with a diagram. If you are unable to do out on the last one, it's out on the first, then it's a matter of looking at the diagram and just see how you go from point to point. I have to travel along the vector direction that you know. So vectors at this level, in simple terms, is just how you go around the diagram from point to point, and you have to go along the vector direction that you know. Another thing, as soon as you find out something on a vector diagram, you put it on the diagram, especially the pathways. Put them on the diagram, populate the diagram, all right? Question time. All right, we're going for about our hours at top. Question time. So we want to do a past paper. We want to do 2025, June 2025 to begin. All right. I will just doing the questions at the back. This is June 2025. All right. This is June 2025. I want to do the questions at the back. See, this is 2025, last year exam paper. So the recent exam, so you know that what question we're talking about are of the standard that you expect to know now. Right? Recent exam. All right, so we're going down to the last part of the book, or the paper, and we're looking for the topics that we're doing. Circle theory, bearings, matrices, vectors. So we'll do that set of question, and then we can maybe take a little 10 minutes break, and then we'll come back, and we'll do another thing. We'll just do that until we finish. I might give you one to do, take a break, give you one to do, and then we continue, all right? Or I can just work them out for you, and you can always go and do them afterwards. You have to be disciplined and go and do them afterwards. That's a fair one. All right? But watching me do them is not enough, guys. You have to put pen to paper. Even people online, I'm talking to you as well. Watching somebody do the questions is not enough. That is one of the drawbacks these days. People just tend to watch people do questions and then understand when the person do it, but it's your time to do it. It's a different kettle of fish. You have to do the work yourself. Put pen to paper and do the questions yourself. If you have videos and so on to help you, do the question and then check the video. Don't just be watching somebody solve the question. You're not learning anything that way. Fact of the matter is that if that is all that was needed, everybody in the Caribbean would have get straight ones, straight A's. Because there are so many persons online solving all the questions there. There are so many persons online working out all the questions. That is not good enough. The pass rate in the Caribbean is still 30%. It's a 70% of people failing. And the 30% who pass is not even high quality pass. The majority of them getting grade 3. Very few people getting grade 1s. But not in this class. This class are high percentage grade, high grade classes. So most grade 1 in class and by that foolishness. Oh, I'm sure telling you from now. All right. Anyway, so question 9. Question 9. So question 9 is really the topics that we're doing at the start. So that's a bearings question on the screen, guys. That's a bearings question on the screen from 2025. Let's go. Question says, a ship sails from point A to point B, which is 15 kilometers from A on a bearing of 040 degrees. So they have given us the direction from A to B at a bearing right here, 040 degrees. And what you want to do, they're going to ask you to do it anyway. You populate the diagram with the information. Okay, you don't want to have to go reading to find information. Everything they tell you, put on the diagram. Look, boy, pay attention. Right? So the distance is 15 kilometers from A to B right here. Well, they didn't put B, so this must be B. And if this is 0, 40 degrees, it has to be this angle is 0, 40 degrees. So from here to B is 0, 40 degrees. So it must be this angle they're talking about, clockwise from the north line here. So I'm going to put it on. This angle is 40, not 40 degrees, 42 degrees. So this angle is 42 degrees. The bearing is 0, 42 degrees, but the angle is 42 degrees. I'm just writing the angle. I'm not writing the bearing. And the distance is 15 kilometers. This distance is 15 kilometers. Put on the diagram. And up here, so must be the point B. All right? Let's continue. It said the ship then sails to sea. So from here now, it's sailing to sea. So it's going in a different direction. You're going on a different bearing now. It's now sailing to sea. All right? Which is 19 kilometers from B. So this distance is 19 kilometers. Let's put it on there. 19 kilometers. And it's on a bearing of 130 degrees. It means that the bearing of this direction down here, so, is 130 degrees. Direction given as a bearing. That direction given as a bearing is 130 degrees. It means that from this north line, from this point, clockwise from this north line, the bearing angle this way, clockwise, to the direction down here is 130 degrees. So that angle inside here is 130 degrees. But good at that so far? But okay with that? Yeah? It said the following diagram shows a sketch of the ship's journey. It says, on the diagram, insert the bearing of 042 and 130. See them here? I put them on there. I put the 0 in front. Since it says put the 0 in front, let me put the 0 on this. So this is my 42 degrees angle. I'm going to put the 0 in front. See, there's 042 degrees right in there. That's what I want. I've also installed the distances on the diagram. Calculate the distance between the towns, between town A and town C. So they're basically asking us for this distance across here. This distance they're asking us for. This. All right? Now we have to work smart. To find that distance, we need an angle inside the triangle. To find that distance. Because this triangle is not a right angle triangle. We're going to have to use sine rule or cosine rule in it. All right? Now we have these two sides. If we can find the angle between them, then we can use cosine rule to find this side over here. But I understand that. And it is always the case where you can find this angle inside here. You have multiple ways to do it. All right? Let me show you an easy way to do it. Now, a lot of people say, okay, find this angle over here so first by remembering that those two add up to 180 degrees, but they are co-interior angles. And then now find this one by doing 360 minus these two. But it's actually an easier way to find this angle between here. So let me show you. An easier way to find this angle over here is to take this north line and break the angle like this. So break the angle that you want with the north line like this. And when you break the angle with the north line, you basically have Z angles over here. So this angle over here, so, is equal to this angle over here. So see the Z here, Z angles, alternate angles. Because this line and this line parallel. Right? So you have Z angles. So the 42 degrees that is out here is the same 42 degrees in here. All right? So inside here says 42 degrees right here. This half of this piece of the angle is 42 degrees. Up to here, so. Then over on this side now, this is a straight line. Total angle on a straight line is 180 degrees. Up to here says 130. So the piece inside here so must be 50 degrees. And to me, that's the best way to find this angle each time you have to find it. Break the angle with this vertical line, Z angle on one part of it, put angle on a straight line on the other part of it. So inside it says 50 degrees. So it means that that red angle between the two sides that we want is the sum of these two, 42 and 50. That is what? 92 degrees. But I go to that. That's a good way to find that angle in there. I know that we have that angle in between them. You can use cosine rule now to find this side. Because we have two sides and an angle between cosine rule. So let's do it. Cosine rule. So I say, notice, you did not ask for this angle, you know, so you have to know that you need it. Right? Some questions ask you for it. This one don't, did not. So not every question will ask you for everything that you need. You have to figure out what you need. And through practicing, you'll eventually learn the thing that you need in a question. But when you do the question that asks you for it, those questions ask you for it and you see how you use it. So when they give you a question that does not ask for it, you're supposed to say, but normally when them ask a question like this, they ask for that angle first. So if they didn't ask for it in this question, you need to find it anyway. So we're going to use cosine rule and find that distance. You see it here now? Cosine rule for AC. All right, don't say C. Cosine rule for AC. So we're going to say, all right, start like Pythagoras theorem. Treat this like a hypotenuse, treat this like a 90 degrees. So start out like Pythagoras theorem. So it's AC squared would be equal to 15 squared plus 19 squared. If it was a right angle triangle, but it's not. So you have to subtract a piece. Where you subtract? Twice the product of these two. You have to remember, 2 times the 15 times the 19 times the cosine of the angle between them, which is 92 degrees. And then now, because this was 81, instead of squaring this, we can square root this and take off the square and then square root this side. And then just put everything here in the calculator and do one calculation. There's no need to be working out each part. That's waste of time to be working out each part. CSEC expects you to use the full capacity and capability of your calculator. All right? So I'm going to work it out here on the screen. So it's the square root of 15 squared plus 19 squared minus 2 times 15. Notice I'm not putting the brackets. I was putting 2 times 15 times 19. Because it's easier to type in the calculator that way. Times the cosine of 92 degrees. And make sure your calculator is in degrees. Look at the top of my calculator there, you see the DEG up there. So some calculator will have the DEG, some calculators will have a D. Make sure your calculator is in degrees. All right? Because if it's in a different unit of measure and angle, then the answer is going to be rough. Make sure it is in degrees. So I'm getting 24.6 kilometers. So I'm going to put the 24.6. And when the answer is not exact and they don't tell you how accurately they want the answer, give it to 3 significant figures. So the AC then is 24.6 kilometers. And you put it on the diagram. This side equals 24.6 kilometers. You work it out, put it on the diagram in case you need it again. So I put the equal in front because we worked it out. It was not given. Right? What else I want on this question? Now I want the bearing of A from C. So you're going to do this bearing now, guys. You want to put it on the diagram, draw it on the diagram so you can see which angle you want. So I want the bearing from C to A. Always note that the bearing is at the from position, from which direction you want. So it's from C. Say from C. This is from C to A. So you want the bearing in the direction CA. You want the bearing in the direction CA. So you're going to put it on the diagram, draw the angle that you want, and then figure out how you're going to get that. I want to give you like a tip that you must remember in this year. So you want the bearing from here so to up there. So that's what I want. The bearing from C to A. So the question wants the bearing of this direction. You want the bearing of this direction. All right? So the diagram kind of messy, but the bearing of that direction would basically be the clockwise angle from the north line here, this way, all around here to this. That's the angle that I want. right? And 99 or 95% of the time, when they want that angle, the bearing angle from this point, the angle inside the triangle at this point will play a part in the calculation. So I like to call that angle alpha. And see how it plays a part in the calculation. You're going to need to calculate that angle. All right? So we want that red angle that I've drawn. All right? Now, this angle up here was 130. So this angle down here, so it's 50. Why is it 50? Because these two angles are supplementary. They add up to 180. Another way you could know that that is 50 is by the Z. Because remember, this angle inside says 50. So if we look at the Z, up this one, down this one, up this one, you have the Z. So this inside it says 50, so inside it says 50 as well, right? So it need that angle is 50. So this angle inside it says 50 degrees. So since that angle is 50 degrees, the bearing angle that we want, which we're going to call theta, becomes 360 degrees minus the 50 and minus the alpha. But I said that. So we're going to need to find the alpha. 360 minus the 50 and minus the alpha. That's what we're going to want. All right? Well, let me show you. Could have found it over here as well. Pay attention now. Could have found it over here as well. Look. Remember, I want the bearing of this direction. So okay, what I could do is extend the direction like this. It's that direction I want to know. That is still the direction C to A now. This is still the direction C to A. It's the same direction, don't you? So the direction hasn't changed. And I can calculate the bearing up at this point. And the angle that I would want would be this angle CMD. And if I'm doing the angle there, then the angle inside the triangle will play a part in the calculation. This one, which is beta. It's called that beta. So how would I get that big red angle now? It would be the 42 plus the beta plus 180 degrees right there. So, but I can see that the big red angle there would be 42 plus the beta and then 180 degrees. That would find the bearing angle there as well. But that's not that. Bearing is a direction. It's an angle. It's a direction given as an angle. So I could work it out there. So, but I think most persons would do it down here. So, which you're going to get the same answer. All right. So let me do it down here. So for down here, it's going to be theta is the angle that we want. And we're going to need the angle alpha. Theta is the bearing angle. We're going to need the angle alpha. Now, look at the diagram now. How can we find the alpha? How can we find the alpha? Find the alpha, we're going to use sine rule. Why are we using sine rule? Because we know of this pair of angle and side opposite each other. Where we know both of them. Once you have that, you can use sine rule. So in the sine rule, we're going to be using this pair along with the angle and that pair. That's how we're going to pair it in the sine rule to find the alpha. All right? So let me do it on the screen. You can see. So let me do it right here. And do it right inside here. So you can see. So I'm going to use sine rule for alpha. Because we're going to need it to find the pair, right? So because you want to find the alpha, you start with it. So you're going to say sine of alpha over the side opposite alpha, which is the 15, equals sine of the angle that you know, which is the 92, over the side opposite to the 92. So sine of 92 degrees over the side opposite the 92 degrees, which is 24.6 degrees, kilometers. And then you transpose it to find the alpha. Or you transpose it to find the alpha. Take the 15 and multiply it up here first. And you're going to take the inverse sine. So firstly, you will get sine of alpha equals 15 times the sine of 92 degrees divided by 24.6. Let me shift this over a bit. And then you will take the inverse sign in front of this because it's alpha you want. So I'm going to erase this sign and put sign to the -1 in front of it. And bracket that up. That calculation will give me the alpha. All right? So let's go and do it. So the alpha is sign to the -1 of a fraction, put it in the calculator, 15 times the sine of 92 degrees divided by 24.6. That's 37.5 degrees. 37.5 degrees. That's my alpha. I'm going to copy this down and move it down. I don't want that. I want this. I'm going to put it down here. So this is my alpha. All right, I've worked totally. But for this question, we recognize that the bearing of A from C is equal to theta on the diagram. Where the theta on the diagram we said is 360 degrees minus the 50 degrees and minus the alpha. Right? That's what we said. This bearing angle theta right now is 360 minus 50 and minus alpha. Because the total angle around the point would have been 360. Right? I was subtracting the 50 and the alpha. But I know how we get the 50, right? Because remember, because this line and this line parallel. Because these two are not lines. This line connect them. Then the angle inside here and the angle inside here are what we call co-interior angles. They are up to 180 degrees. So the one up here says 130. Then the one down here must be 50. And the most add up to 180 degrees. They're called co-interior angles. Another way we could see it, that angle is 50 degrees. It's used as Z angles. So down this parallel line, down this transversal line, back up this north line, we have a Z. So remember the angle inside here, so it's 50 degrees. So the alternate angle over here is also 50 degrees. So that's two ways we could get that as 50 degrees. All right. So this is the calculation. And we know the alpha now is, we worked out already. This alpha is 37.5. We're going to use the alpha right here. So the theta angle that we want comes 360 degrees minus 50 degrees and minus 37.5 degrees. And let's use the calculator, work that out. So it's 360 minus 50 minus 37.5. So we're getting theta equals 272.5 degrees. Put 3 digits for your answer, 273 degrees as your answer for bearings. I must always give a bearings with three digits as the answer bearings. That is it, guys, for that question. Very good? All right? Online, you good?
Yes, sir.
All right, let's go to the next one. So next one here is circuit theory, guys. Let's practice some circuit theory with this one. All right, let's practice some circuit theory with this one. This one says points L, M, and P lie on the circumference of a circle whose center is O. So this is a center O. So it means that that's a diameter. Remember, I'm going to subtend by a diameter at 90 degrees. So right now, this angle is 90 degrees. Right here, 90 degrees. By subtend by that diameter. I'm going to subtend by a diameter at 90 degrees. It says NP is a tangent. So that's a tangent, guys. So once you have a tangent there, you're supposed to be thinking tangent and radius, tangent and chord. So tangent, that's a tangent. That becomes a tangent and a chord. So the angle between them there, tangent and chord. So this angle is going to be equal to this angle up here. But the angle between a tangent and a chord equal to the angle obtained by the chord up here, the circumference. So before we start to know that this angle and this angle equal, those two angles equal, these two equal. Also know tangent and radius. Tangent and radius is 90 degrees, right? This is 90 degrees. So looking out for the things as you go, all right? looking out for the things that you do. It said the tangent and the OMN is a straight line. So this is a straight line out here. So it means that that's a right angle triangle. You know? That's a right angle triangle, right? Because this angle is 90 degrees. All right. So that's a right angle triangle. What else? It says the line PL is a diameter. Yes, that's a diameter. Diameter subtends 90 degrees. And the angle ONP is 24 degrees right here. So everything that they have set up here is on the diagram. So we don't have to worry. Everything is on the diagram. It says calculate the value of each of the following angles, show detailed working where necessary, and give a reason to support your answer. The reason is a rule, one of the rules. All right, first angle I want is angle PON. PON, angle at O, the angle right here. Angle right here. Now, we did say that this is a right angle triangle. Why is it a right angle triangle? Because angle between tangent and radius is 90 degrees. So that angle is 90 degrees, then these two angles are up to 90 degrees as well. Because the total angle in that triangle is 180 degrees. See that? So therefore, this angle becomes 90 minus 24. But that's a right angle triangle. Or if you like, you could say that this is 90. You could say that this is 90 because of the tangent and the radius. And then total angle in the triangle is 180. So you add up these two and subtract from 180, you get this one. All right? So that looks like 66 degrees to me. But you have to write out the rules. So I'm going to write that these two add up to 90, right? This angle 1 right here. So that angle is equal to 90 degrees minus 24 degrees. Because these two add up to 90. Because this one down, I'm going to declare that this one is 90. Because the angle between a tangent and a radius. So I'm going to state that. So that one is 90 degrees. What does this work out to? Minus 21st and then minus 6, well, that's 66 degrees. I want to tell the examiner when I'm reasoning that this angle is 90. So I'm going to say angle NPO. Angle NPO equal 90 degrees. Why? Angle between tangent and radius is 90 degrees. That's the reason why that is 90 degrees. And then no, because that is 90 degrees, that's why this is 66, because the total angle in the triangle is 180. So the reason for this now is that total angle in the triangle is 180 degrees. Total angle in the triangle OPN is 180 degrees. Total angle in triangle OPN, triangle OPN is 180 degrees. And if this don't understand 90, then them two must add up to 90. That's why we just did 90 minus 24. So this angle is 66 degrees. And you find, you put on the diagram, guys. Anything you find, you put on the diagram same time. That angle there is 66 degrees. All right, that's the first one. Which angle do I want next? Next angle I want is angle PLM. Angle PLM, where is that? PLM. All right. So let me show you how you can figure this out now. So you want to find this angle up here now, right? This angle I want. So we can't see it right off the bat. You want to find a chord or the arc that is subtending the angle and see what else that chord or arc is doing. How do you find it? You come back until you reach the circumference. Come back along the lines making the angle until you reach the circumference, which is right here. And come back along this side, you reach the circumference, which is right here. So it is being subtended from these 2 points. So this is the arc subtending the angle, or you could say this is the chord of subtending the angle. Let me draw the chord in a different color. So this is the chord. So most time you work with a chord, right? Remember, it's an arc or a chord that subtends an angle, right? You're always looking out for that. Now, this same chord is subtending this angle of 66 degrees at the center. Right? That same chord is subtending that angle of 66 degrees at the center. See it here? If I draw that line to there and draw this line to here, the chord is subtending angle at the center. But the center rule says angle at center is twice. So this angle is 2 times that one. So this up here must be 33 degrees. Because the one at the center is twice. So the angle of the circumference is half the one at the center. The one at the center is twice on the circumference. So that angle up there is 33 degrees because it's half the one at the center. The one at the center is twice. So this angle up here is 33 degrees. Half of 66 is 33 degrees. So tell the examiner that it is half of 66. So this angle equals half of 66 degrees, which is 33 degrees. Because the one at the center is 66. The one at the center is twice one circumference, right? So I'm going to write angle at center is twice angle at circumference. That's your reason. You want to continue the statement and say when subtended by the same arc or subtended by the same chord, they can continue. But for me, if you write this in the exam, they'll give it a marks. Angle at center is twice angle at circumference. That's it. All right. The one at circumference is 33 because the one at the center is 60. The one at the center is twice. That's it. Next angle I want, angle PMN. Angle PMN. Let's look at the diagram for that. Angle PMN. Where's P? PMN. All right. So I want this angle out here so now. This angle I want next. PMN. All right. So to get that angle, what we can do? We are working this triangle. All right. We're going to get that angle. Once the total angle in this triangle, total angle in this triangle is 180, right? So I kind of need this one, don't it? See that? But this one equal that one up there, so. Because the angle between the tangent and the chord. See it? So they're asking us for this one. If I can know this one, then that'll be nice. Because I could say total angle in the triangle is 180. Right? But this one down here, remember, is equal to the one up there. So why? Because this is the angle between this tangent and this chord. And the angle between a tangent and a chord is equal to the angle subtended by the chord up here. Right? So because the angle between this tangent and this chord, it's going to be equal to the angle subtended by the chord. So this angle down here is 33 degrees in here. It's 33 degrees. It's going to be 33 degrees. Angle between tangent and chord, rather better. Angle between tangent and chord equals angle subtended by the chord as a tangent and chord rule. And then now, total angle in this triangle is 180. So this angle out here that we want now becomes 180 degrees minus the sum of these two. Minus the 33 and the 24. That is it. Whatever that works out to be. Somebody work that out from the money. 180 minus, what is that? 57. Huh? 113. Huh? How much? 133. 120. Make sure you're right, you know. All right, so let's go and tell the reason. So first I will tell them about this angle. First I will tell them about that angle. Let's do it over here and never copy it though. All right, first we have to say this angle which is MPN. is 33 degrees. But if I say angle MPN equals 33 degrees. What's the reason? Because angle between, this means angle, this means between. Angle between tangent and chord equals angle subtended by the chord. All right, that's why this angle is 33. And then the over here is clear total angle in a straight line is 180, right? Total angle in a triangle is 180 degrees. So I'm gonna write it. The next reason is that total angle in triangle PNM is 180 degrees. Total angle in triangle TNN is 180 degrees. So this is what we read. This is what our reasons. That we'll have to put down here for this one. So to put that, this angle becomes 180 degrees minus the 33 and the 24. All right, and the reason for this one is this, and then we get the 33, get the 33. 33 that we're using here is for that reason. All right, that's it. But good? Yeah? All right. That's a circle theory question that we just did. I think we have vectors and matrices in this question. Yes. So I'll touch some vectors on this, touch some matrices. I'll give you a short break. We'll come back and do another paper. All right, let's go. And I should put out the paper that we're going to do so you can think about it in the break. And this question says, the diagram below shows OPQL is a parallelogram. And anything you read up here that's not on the diagram, you want to put on the diagram. As I give you the information, put it on the diagram. You populate the diagram so you can see how you get yourself around when you go around, right? So it says OP is a vector R. Vector OP is R. See, try to yourself. That's on the diagram. It says OL is S. See down here, so OL is the vector S. All right, that's on the diagram. What else them say? Them say T is a point such that PQ equals QT. PQ equals QT. You know what that means? It means that this is the midpoint on this line. All right? So whatever vector this is, that's the same vector. Watch this now. You must love when they give you a parallelogram. Because remember, in a parallelogram, the opposite sides are equal vectors. Why is that? But the opposite side, hey, you can go second that. But the opposite sides are equal in length and have the same direction. All right? So these two sides are equal in length and parallel, so they are equal vectors. So we can populate the diagram. So the vector down here, so it's S, and the vector across here, so it's also S. Let's put that on the diagram. Put on everything on the diagram that you know. Let's put on in red. So this vector across here is S for that reason. But understand that reason. Then because this length and this length is the same, and them also have the same direction, then it means that the vector over here is also S. This vector is also S, that have the same length and same direction as that one. So this vector is also S. Put them on there. So this is also the vector S. From Q to T is also the vector S. So far, so good. Then another thing is that because this side and this side parallel and equal, they are also equal vectors. So if this vector is R, then this vector also going up here is R. Put on the diagram. So I'm put it over here. This vector going up here is also vector R. So far, so good? Well, I like to underline my vector components. I'm going to put underlines under them. I like to underline my vector components so I can distinguish it from scalar components or scalar quantities. All right? What does it tell us? They said M is the point M, see point M here, it divides the line PL, it divides this line in the ratio 2 to 1. I like to put the ratio on the line so I can see the parts, 2 to 1. So 2 must be this part and 1 must be the short part. So the line is divided into 3 equal parts, 3 parts, 2 parts up here and 1 part down here. So the total parts on this line is 3. 2 up here, 1 down here. So you then could say this line is 2/3 of the whole line, don't it? 2/3. And you also can say that this part down here is 1/3 of the whole line. So that when it divides it in the ratio 2 to 3, there are 2 parts here, 1 part there. So the total parts on PL is 3 parts. This is 2/3 of PL. This is 1/3 of PL. We have to know that. Very good. All right? That's what we need. It says, find in terms of R and S. That means R and S must be in the answer. The answer must be just with numbers, R and S. So the answer must be in terms of R and S. That's what that is. First I want is the vector PL. Now, PL can be found easily. Why? Because we know the position vector of the P and we know the position vector of the L. We know both of them. When you know the position vectors, you can simply use O times the last minus O times the first. Because I know the position vector of the P and I also know the position vector of the H. I don't need the diagram right now to find this one because I know the 2 position vectors. Right? So I can just use OL minus OP. O times the last minus O times the first. The OL based on this is S. And the OP based on this is R. But look here now. What we calculate as our answer must be consistent with the diagram. So to go, this is saying to go from P to L, you're going to go at S and then a minus R. Or you can go the opposite way around as well. It can be minus R plus S. Same difference. So let's look on the diagram and see who could have gotten it from the diagram as well. To go from P to L. See it here? Go along the vector direction that you know. We cannot come across here yet. Because we don't know that pathway yet. So these are the 2 vector directions connecting to L. Or it can be up here as well. So go from P to L. We can come across here, so using the S. See there? And then come down here, so using minus R. Why is that minus R? Because I'm going in the opposite direction to the R. The R is this way, up. But I'm coming against the R, so it's minus R. So looking at the diagram, it will be S and then minus R. Minus R will take me from P to S, which is what I have here. Could have also gone the other direction. Could have been said, come down here so first with a minus R and then go across here with a plus S. So it could have been minus R plus S, same thing. All right, but I'm using the O times the last minus O times the first because I have them. Now, the important thing to note now, guys, is that now that you work out PL, it is as if you now know this pathway. You have it here. You can now go along that pathway. You can go the full length of it if you want, or you can go a part of it if you want. So for example, if you want to go now from P to M, it is 2/3 of this. Because the whole vector there now is PL. And if you want to go from M to L, it is 1/3 of this. But the whole thing now is S minus R. Once you find the vector on the path, you can go the full length of it if you want using this, or you can go a fraction of it. And M divides it into 2/3 and 1/3. All right? So you can travel along it now using that vector, the PL. And that's how these questions usually go. What you find first, if you find the second thing and so on. The next thing I want is the vector OM. So we'll look at the diagram to see how we go from O to M. Let's look at it. See M right here, so how do we go from O to M on this diagram? We can go O to P up here so first, and then go P to M. That's my preferred route to go. Why? Because if I'm traveling along this vector, I want to go in the same direction as the vector that I have already. Because we can also go from P to L by doing this. We could have come on to L first and then go backwards this way. If I'm going backwards, that will be minus 1/3 of that, because I'm going in the opposite direction. So I prefer to go in the same path as this is, which is down from P to L. So I prefer to go up to P and then go P to M. So see here, going from O to M is the same as, but equal in vectors means it's the same as. Equal in vectors means it's the same as. So going from O to M is the same as. We're going to go from O to P first, O to P first, and then we're going to go from P to M. P to M. That is how we're going to go from O to M. But the PM is 1/3, not 1/3, 2/3 of the PN. So this PM right here, we're going to put it as 2/3 of the PN. So we're going to write instead OP plus 2/3 of PN. And that's how we're going to get the OM. You understand that? Good? And 2/3 of PN is just 2/3 of this. And the OP is just this R right here. So it's not complicated, guys, not complicated. Let me shift it down and do it on the screen where the diagram is so we can see what we're doing. I'll put it over here. All right? So see it here now. It's going to become the OP is this R plus 2/3 of PL means 2/3 of all of that. So you're going to do 2/3 of the S and then 2/3 of the minus R. So it becomes plus 2/3 S minus 2/3 R. Because we're taking 2/3 of that. And then consolidate the balance. So this is an R term and an R term. And consolidate them. Equals. You see this R? This R is the same as 3/3R. The same as 3/3R. Why am I doing that? Because this have a denominator of a 3. So this is the same as 3/3R. So it becomes 3R minus 2R. That's just 1R, R. And then this is the only S term in it. All right? So this becomes 2/3 S. There, 2/3 S. And then 3R minus 2R is 1R. I just put R, 1/3 R. You can say 3/3 minus 2/3 give you 1/3. 1/3 R. I could still leave this off, you know, and just say something like this. But I've said a whole R minus 2/3. A whole minus 2/3 is 1/3. So a whole R minus 2/3 R leaves you with 1/3. So you could even do that as well. Right? So I know I have different people. So this is the answer. This is OM. That is the vector OM. Right? And we can kind of check if this answer is correct as well. But the diagram and your calculation must match, right? So watch this now. What this is saying, you see, is that to go from O to M, it must go 2/3 in the direction of S and then 1/3 in the direction of R. That's what it means. Let's do it. So it says go two, this is a whole S. That's a whole S. 2/3 S would maybe be about right here, so that would be about 2/3 S. About right here, so 2/3 of the way. This is a whole R up here, so. If I go straight up here, so that's a whole R. I don't want a whole R. I only want 1/3 R. 1/3 R. So 1/3 R would take me right here. So I can accept this answer. This looks like a 2/3 S. And this looks like a 1/3 R. They combine to take me from O to M. So I can know that this answer is correct. If, for example, I made a mistake and put a minus here, so then this would be sending me down this way. The minus would be sending me opposite direction to the R, which I would know that it is wrong. You get me? So sometimes you can check your answer to make sure that the calculation and your diagram say the same thing, that they match. But this answer is correct. So I can copy all of this down and put it in its rightful place. Down here. All right. Then we'll come to this part. Prove that the points O, M, and T are collinear. Remember, to prove collinear points, you need two vectors between the 3 points. Two vectors. And you have to show that those two vectors are parallel and then there's a common point. So you want to decide which two vectors they're going to use. You want two vectors with these 3 points. So we already know that we can use OM. So we're going to use the OM vector. Let's write it down. We're going to use the OM vector for sure, which is 2/3 S plus 1/3 R. And we need another vector. We need a vector with a T. So it's either OT or MT. So look at the diagram and say which one is easier to find if we don't have it yet. So we need a vector with a T now. With the T again. T is all the way out here. So we say we either need OT or we need MT. Which one is better to use? Can I use any one? Show that these two vectors are parallel. These 3 points are collinear. We only need 2 vectors from the 3 points. We have one connecting the O and the M already. That's OM. So the next one we need is either OT or MT. Let me write them out. We need either MT or we need OT. So look at the diagram now and tell me which one is easier to find. The OT out here, so, or the MT right there. So which one is easier to find? Look at the diagram. Which one is easier to find? OT or MT? Answer now, which one is easier to find? To go from O to T. Which one is easier to know? Or you go from O to T? Eh? You are saying it's easier to know you go from M to T? Eh? You say OT. Why you say OT? Eh? Exactly. So even though MT is shorter, it's more difficult to find it. Because OT is obvious. To go from O to T, you just come up here with an R and go out there with a 2S. See it? No calculation needed. If you're going to use MT, you're going to have to calculate something. If you're going to use MT, you can't look at the diagram and know what MT is. You're going to have to do some calculation to find the vector MT. OT, there is no calculation needed because it is obvious and clear how you go from O to T. Come on, guys, we have to make sure so we get this now. It don't make no sense we do more work than we need to do in the exam. So not because the distance is short, I mean say it easier. Shortcut draw blood in vectors all the time. I tell people all the time in vectors. Shortcut draw blood. So it is obvious in this question that OT is easier to find, even though it's the longer distance. Go from O to T, it's obvious. Going along the vector direction that you know. You come up one R right there, so see there that does R. And then it's a 2S. S plus S is 2S. So it's R plus 2S. Take it from O to T. No calculation needed. If I'm going to use MT, I'm going to do some calculations. Why do the mathematics are more difficult to read? So we're going to be using the OT. That's easier. All right? So OT is simply R plus 2S from the diagram. Because it is OT is OP, yes, sir, plus PT. Plus PT. Remember, plus in vectors mean and then. So to go from O to T, go O to P, and then we go from P to T. So it's this one. That is it. So I'm going to write this on the next page now. R plus 2S. So we're using OT instead. We're not using MT. MT is more work. MT is more work. So we're using OT. Do the mathematics the easy way. Come on. So we're doing OT. Also, it is R plus 2S. So we need to now show that these two vectors are parallel. We need to show that the two vectors are parallel. And I spoke about the 3 steps process. One, you get rid of fractions first, because fractions make it more difficult to see the relationship between the values. Fractions make it more difficult to see the relationship between the values. So how do we get rid of these fractions out of this one? What do we multiply by to get rid of fractions out of it? The lowest common multiple of the denominator, which is just a 3. If you multiply this fraction by a 3, no, the fraction's gone. This equation by a 3, no, the fraction's gone. Multiply this equation by a 3, you will eliminate these fractions. Multiply by a 3. So when I multiply by a 3, remember to multiply this over here by the 3 as well. You're going to get 3OM equal, multiply this by 3, cancel the 3 under here, you get 2S. Multiply this by 3, you cancel the 3, you get R. So you get 2S plus R. Okay, so now, see there? You also have 2S plus R over there, so you don't have the other way around. You see that? That is 2S plus R as well. The same thing. All right, so this is also 2S plus R. R plus 2 is the same as 2S plus R. So they're equal. So because they're equal, we can now equate them. We can now equate them. See, we're going to equate these two vectors now. Equate. When you make them equal, you equate them. And when you equate, you put this equal this, or the other way around. So we can write the OT equals 3OM. So we can write OT equals 3OM. And that's what you want. In order to have that, you write out the 2 conditions for coordinated. Don't just stop there. There are 2 things that must happen for you to have coordinate points. And this have the 2 things wrapped up in it. 1, what is happening here? 1, the first thing that happens there, because one vector is a multiple of the next, it means that they are parallel. That's the first thing you must have, parallel vectors. So OT is parallel to OM. That's the first condition for collinear points. They must have parallel vectors. And then they must also have a common point. So the common point here, the O is a common point. So you state it. Second thing you must have for collinear points is a common point. State the common point. O is a common point. So because you have these 2 things, you can draw the conclusion and say, therefore, the points involved, the O, the M, and the T, the O, the M, and the T are collinear. O, M, and T are indeed collinear. And that's how you prove every collinear question. Get parallel vectors with a common point. And you get the parallel vector the same way as you do normally. Get rid of the fractions. You're trying to get them to be equal. They're not equal after you get rid of fractions, you multiply the small one up, make it equal the big one. And when you multiply the small one up, make it equal the big one, then you equate the vectors. And you equate in the sides, the vector side. Equate the vector side. All right? So in this example, I equate the vector side, equate that side and that side. All right? Because these 2 things equal, I can equate those 2 things. So you can see the points in the equation that you're talking about. And that is it. But all right, let's do the matrices part. So we equated them. We put this in the red. Equate them because the 2 of them equal the same thing. That's how we equate them. All right. All right, let's go down to the not the vector, the matrices part. This one gives us 3 matrices, A, B, and C. So this matrix is a 2 by 2 matrix. See, 2 rows, 2 columns. This is a what? The second one is a what? It's a 2 by 3 matrix. A 2 by 3. That's 2 rows and 3 columns. And this one also This one also is a 2 by 3. 2 rows, 3 columns. That also is a 2 by 3. What do I want us to do with them? They say find a matrix AB plus C. So AB means that we're going to have to multiply these two, and then we're going to add C to it. They're almost giving it away, because when you multiply these two, you're going to get a matrix with the same order as that. And if you're not sure, you can work it out. Look, you can work it out. Let me put it up here for you. So you're doing AB plus C. Let's so what kind of matrix we get for AB? So for AB, let's look at it. AB is a 2 by 2 times a 2 by 3. This multiplication is possible. Why? Because the number of columns in this one is equal to the number of rows in this one. They are equal. So the resulting matrix is going to have the same order, same number of rows of the first one, which is 2, by the same number of columns of the second one, which is 3. So the answer is going to be a 2 by 3 matrix when you multiply it. But after that, so you set it out, and we're going to go through the process of multiplying this one step by step. All right? To see what the process is. All right, let's go. So we'll work out the AB first and then add it to the C. So we'll work out the AB by itself first, and then we'll add the C to it afterwards. All right. So let's work out AB. What space we have? All right, we have some space. Let's work out AB first. So AB becomes equal to 3, 2, 5, 4. That's the A times the B, which is 4, 0, 2, 3 minus 1, 7. All right. Now remember, when you multiply matrices, guys, you're going to multiply the rows of the first matrix. That's these 2 rows. Some teachers circle those 2 rows. I just put a line across here to remind me. You're going to use these 3 columns. I tend to just put a line down here to remind me that I'm using the columns. And we did say the answer is going to be a 2 by 3. Right? So we're going to put a 2 by 3 placeholder and then put the values in there. So the result of this, we can just add the C over here. So in the meantime, I'm going to just put the C over here. So I'm going to write it like this: AB plus C. AB plus C. I just put the plus C over here. So plus C. The C is this, right? So adding the C, which is 4 minus 1, 2, 7, 3 minus 5. That is C. So this is the AB we have to work out first, then add the C afterwards. We have to work out the AB right here. So we're going to work it out right here. So it's going to have 2 rows and 3 columns like that. So you're going to have values in those positions. All right? So how you know which row and which column to multiply to get these values? Let's go. This first value is positioned in the first row and the first column. So to get it, we have to multiply this first row by this first column. That's how you know. First row, first column element you want, you multiply the first row by the first column. So how do I multiply that row and that column? Remember now, I'm using this row and this column. How do I multiply them? It's first element in the row times the first element in the column plus second element in the row times the second element in the column. So it's first element times first element, second element times second element. First element times first element, second element times second element. 3 times 4 and 2 times 3. 3 times 4 is 12, 12, and 2 times 3 is 6, plus 6. That's the first value. Then the second value here is positioned in the first row and the second column. So we have to now use this first row and the second column. All right. So I'm going to use this column now. I do them the same way. First element in the row and the first element in the column, the second element in the row and the second element in the column. So it's first element times first element, second element times second element. First element times first element, second element times second element. 3 times 0 is 0. and 2 times -1 is -2. And the last value out here is in the first row, third column. So to get it, we're using this first row with this third column. So using the third column now. Over here. Same thing again. First element times first element, second element times second element. So it's 3 times 2 and 2 times 7. 3 times 2 and 2 times 7. 3 times 2 is 6. 2 times 7 is 14. Let me shift over this bracket a little bit. Then we come to this element on a here, which is now in the second row, first column. So to get it, we're going to use this second row with this first column. So shifting things now. So using this second row with this first column. I do the same thing again. First element times first element. Second element times second element. First element times first element. Second element times second element. 5 times 4 is 20. 4 times 3 is 12. And the value here is positioned in the second row, second column. So using this second row with this second column now. So using the second column now. Again, it's first element times first element, second element times second element. First element times first element, second element times second element. 5 times 0 and 4 times -1. 5 times 0 is 0 and 4 times -1 is -4. And the last value out here is positioned in the second row, third column. So to get it, you have to multiply this second row by this third column. Second row, third column. So second row, third column. First element times first element, second element times second element. First element times first element, second element times second element. 5 times 2 is 10. 4 times 7 is 28. All right? And we're still adding back this matrix over here. 4 minus 1, 2, 7, 3, -5. That's where the final answer. Because this right here says A, write the values above them. Write the workout in purple. So this workout to be 18 right here, so this is -2. This right here says 20. This right here says 32. This right here says -4. And this right here is 38. So this value right here now, in the answer, is 18 plus 4. That's 22. -2 and -1, that's -3. 20 and 2 is 22. Then 32 and 7, how much is that? 39. Then -4 and 3 is -1. Then 38 and -5 is 33. And that is the answer right here. What go to that? All right, that is it. That's the multiplication practice. All right. Next question. It says find the inverse. Find A to the -1, which is the inverse of A. Let's write down what A is. A is the matrix. What is it again? A is the matrix 3, 2, 5, 4. 3, 2, 5, 4. So remember now, A to the -1 equals 1 over the determinant of the A times the adjoint of the matrix A equals 1 over the determinant. Remember, the determinant is the first diagonal product minus the second diagonal product. The first diagonal product is 3, 4 is 12 minus the second diagonal product is 2 times 5 is 10. Multiplied by the adjoint matrix of A. The adjoint matrix is obtained by interchanging those two on the first diagonal. Switch them around. So 3, 4 becomes 4, 3. Then leave these two where they are. Don't switch them around. Just change the sign. So this 2 up here become -2 in the same place. This 5 become -5 in the same place. And this under here is just a 2, right? This under here is just a 2. The determinant is just a 2. So now it's like you're dividing each of these values by the 2 to get the final answer. And so a to the -1 becomes 4 divided by 2 is 2. -2 divided by 2 is -1. -5 divided by 2 is -2.5. And 3 divided by 2 is 1.5. And that's the answer right here. That's a to the -1. But all right, that online, everybody good?
Yes, sir.
All right. Let's continue. Next part now says you have to write down, see, it's don't need no calculation, now write down the matrix which represents the product a times a to the -1, which is something that you should know, because that's one of the items that I must know sheet. The product of a matrix and its inverse is the identity matrix for multiplication. A times a to the -1 equals the I matrix. And the I matrix is 1, 0, 0, 1. That is it. Start with a 1 and end with a 1. 1, 0, 0, 1. This is the matrix that operates just like the number 1. That's what a free mark on the exam paper and say, write it down. No calculation needed. Just write it down. All right, and that ends this paper. End of this paper. All right, so I'm gonna give a little short break. It's now 6:25. Let me put the clock up there. How much break gonna want? Not more than 5 minutes. I'm going to 10 minutes. I'm too lazy. 10 minutes break. I will come back on a different paper. 10 minutes break. Guys online, can see the screen? Students online, can see the screen?
No, sir.
No, sir.
Yes or no? You're not seeing the screen?
No, sir.
Since when you're not seeing the screen? Since when you're not seeing the screen? You saw the solution I was doing a while ago?
Yes, sir. It's just when you put on the 10 minutes.
When I put on the 10 minutes, it came off. I don't know where that is.
Yes, sir.
Hold on. So you see the 10 minutes? You see the minutes cutting down? Or the screen gone altogether?
The screen is black.
Oh, this is weird. It's weird. Gotta fix this before start. I want to do 2023. January 2020. Hey, am I right? Huh? Am I right? Good. Deliver dinner. All right, good. All right. Huh? No? Oh, who is it? Huh? Oh, okay. I try to solve a little issue here. So here, the screen gone on, and I don't know why. Yeah, yeah. Man. I just stop sharing and start share again. So, start share again. Oh, it's quick though. Stop, stop. I give them 10 more minutes. Time fly quick. I'm trying to find which paper I'm going to use on the 18 principal formulation. Session is being recorded online. That's my channel. So anybody want to watch the recording, it's going to be available there. Can we do this one afterwards? Transformation. I didn't want to do transformation. That's straight vector, straight matrices. So, can do it. This paper there. I still do it for the marathon now though. Sixteen. Then 40. Hmm? That one for the upstairs. Right above. So the same place, that one bathroom right above it. Go up the step on. Go up the urban top. I'm soon start. Time up, you know. Time up. Call them. Tell me start them back now. Them get 20 minutes. This song, this song. Oh, this song. January 2021. All right, guys. Let's do January 2021. All right, let's go. The 29% panel. All right, ready. So this is January 2021 exam paper. All right. So as is January 2021, looking at number 9, 9, 9 and 10. Let's see, 8, 9 and 10. Now that's 9 and 10. It's 9. Not doing that. So it's okay. Each question is 2 parts. So we do 9 and 10. 9 and 10. All right. So this is cover the topics that we say we're doing today. All right. Good. All right. So circle theory question. It says in the diagram below, A, B, C, and D are points on the circumference of a circle with center O. It says AOC and BOD are diameters. So these are diameters. That's a diameter. That's a diameter. But diameter subtends 90 degrees at the circumference. Diameter subtends 90 degrees. It says AB and BC are parallel. So once you have these parallel lines, you must be thinking about Z angles and co-interior angles. So for example, when you connect those two parallel lines with this form as Z, this angle in here and this angle in here equal. Those angles equal right now. And then also, if I join these at the bottom down here, then this angle and this angle, they add up to 180 degrees. That we call the co-interior angles. They're like angles in a U. All right, so once you have parallel lines, you're thinking about that. Those parallel lines are also connected with this one. So the same two parallel lines, they're also connected with this. So it means then that these two angles are equal. They're alternate angles. So right now the R equals 2P. Right? Z angles. So you're looking out for those things. Once it's the parallel lines, that's what you're looking out for. Those things you're looking out for. All right, next one. It says state the reason why angle ABC is 90 degrees. Angle ABC right here is 90 degrees. Why is it 90 degrees? Subtended by this diameter. Angle subtended by a diameter is 90 degrees. Because the angle subtended by a diameter is 90 degrees. All right, so the angle is 90 degrees because angle subtended by diameter. And this diameter, I can name it. It's diameter AC, that is subtending is 90 degrees. Angle subtended by a diameter is 90 degrees. That's why it is 90 degrees. Next one. It said determine the value of each of the following angles. Show detailed working where necessary and give a reason to support your answer. Angle BAC. Angle BAC right now. Angle BAC. All right. Watch this now. That's this angle I want up here, right? That's 2P. But right now, we focus on this triangle. We just said that this angle is 90 degrees, right? That's a right angle triangle. So these two angles must also add up to 90 degrees. Because the total angle of the triangle is 180. So the 2P and the 3P add up to 90 degrees. But I can appreciate that. The 2P and the 3P add up to 90 degrees. So that's what we're going to do to find it. And then we'll find P, we'll just multiply by 2 to get angle BAC. All right, so we're going to say that first. So first we're going to say, to find this, we're going to say 2P plus 3P equals 90 degrees. That's 5P equals 90 degrees. So P equals 90 divided by 5 is how much? 9 divided by 5 is 18. 18 degrees, right? 18 degrees. What I get that? P's. P degrees, them have P degrees. So the P is just 18. Because them have P degrees, the P is just a number. And have P degrees, so the P is just a number. So don't need degrees on this. The P is just a number. And the reason for this, because total angle in that triangle is 180 degrees. And we already have the 90. So the total angle in triangle ABC is 180 degrees. And one of the angle was already 90 from up here. Right? This one is already 90. So these two must also add up to 90. So the angle that I want, therefore, is 2 times 18. So you can say, therefore, angle BAC, which is equal to 2P, is equal to 2 times 18 degrees, which is 36 degrees. So that angle is 36 degrees. But the angle BAC is 2P, right? BAC is 2P. Let's put on the diagram as defined. So this angle is 36 degrees. All right, which angle do I want next? Next angle I want is angle Q. Angle Q is this angle. So that angle, if you look, it is subtended. If you come back till you reach the circumference, come back along the sides until you reach the circumference, you know what is subtending it. So that angle Q is being subtended by this chord. And that same chord is subtending 36 degrees up here. So these two angles equal, but they are subtended by the same chord. Angles in the same segment subtended by the same chord are equal. So the Q equals 36. About that, same segment rule. Q equals 36. All right. So this angle here is also 36. So Q equals 36 as well. So let's go down here and write it. Q is 36. Q equals 36. I don't put a degree on, well, let's say angle Q. So let's write 36 degrees. And that's because angles in the same segment are equal. Angles in the same segment are equal when they are subtended by the same chord. All right, next angle I want is going the wrong way, Mr. Shaw. Next angle I want is angle R. Angle R next, let's see. Angle R next. Angle R is this angle right here. Now, that angle is equal to 36 as well. Why is that equal to 36? Because this is an isosceles triangle. So that's a radius and that's a radius. That's an isosceles triangle. So these two angles down here are equal. So the angle R is also 36. Somebody can say that? Angle R is also 36. Another way we could get it, that is 36. That remember that angle over here, everything over here is subtended by this diameter. So the whole of this angle is 90 degrees. That angle is 90 degrees. Right? So if that was 90 degrees and this was 3P, then this remember had to be 2P. And the 2P is 36. But I think better would just use isosceles triangle. You say that it is 36. So the R is also 36 because of the isosceles triangle. So this is also 36 degrees. So everything in this question is 36 degrees, they look like. But that's an isosceles triangle. So triangle OCD is an isosceles triangle. That's the reason. So angle R is 36 degrees. Because triangle OCD is isosceles. Right? Then isosceles triangle because the two radius and radius. That's it. I don't know what I want. So one mark for it, obviously. All right, so that finishes that question. Nice and easy. This question down here is a bearings question. It says from from harbor H, this is harbor H right here. The bearing of two buoys, S and Q, are 130, 185, and 311 respectively. All right. So remember, bearing is a direction given as an angle. So what the basically saying is that the bearing from H down to S is just 185 degrees. It is this angle clockwise, this angle over here, which I've shown, 185. And then the bearing up to Q, up to here, is bearing up to this way. It's going to be all of this angle around you, clockwise again. So that angle is 311 degrees, clockwise from the north line at the front position. So that angle is 311 degrees that I've shown in red. Let's put on the diagram neatly. So this angle around here is 311. Right here, so 311 degrees. What is that? So the whole thing around here is 311. And up to here is 185. Therefore, the angle inside here, therefore, the angle inside here is the difference, right? 311 minus 85. But can you get that? All right. I think that's what they wanted us to do first. Part 1. It says on the diagram, draw and show on the diagram below, which shows a sketch of the information. Insert the value of the angle mark QHS. That's inside here I want. Okay? QHS. I don't want us to put the angle inside here. That angle QHS, we can calculate it right here to show them, becomes equal to 311 degrees minus 185 degrees. Somebody wrote that out for me. What they get? 311 minus 185. What is that? How much? 126 degrees. 126 degrees. And then you put it on the diagram. So inside here says 126 degrees. 126 degrees inside here. (126 degrees). That's it. All right. Let's put on the diagram. Put on the diagram. Next part now says, calculate QS, the distance between the two buoys. They gave us some distance in this question. Yes, they gave us some distance. Sorry, I missed it. They told us that Q is 5.4 kilometers from H. So this distance is 5.4. Let's put on in red. So this distance up here is 5.4. And the other distance down to S is 3.5. See there? 3.5. The distance down to S down here. 3.5. So this one is 3.5. And now I want to find this side over here. So it's cosine rule again, because we have two sides and an angle between them. So that's cosine rule we're going to use to work out that one. Let's put it right here and then copy it down. So it's cosine rule for QS. And by start out like Pythagoras theorem, so it's QS squared equals this side squared plus that side squared, which is 5.4 squared plus 3.5 squared. But it's not Pythagoras theorem, so you have to subtract a piece. So you subtract 2 times the product of the two sides, which is the 5.4 times the 3.5, and then you cosine the angle between them, which is the 126. 126 degrees. Then instead of squaring this side, as we did before, we can square root this, take out the square, and square root everything over here. And then do one calculation in the calculator and get the QS in one calculation. All right, so we can do that. So it's going to be the square root of 5.4 squared plus 3.5 squared minus 2 times the 5.4 times the 3.5 times cosine of the 126, cosine 126, and then make sure to calculate in degrees. That's 7.98. Let's give three significant figures. 7.9. If you want to give two digits as they have been doing here, we can do it as well and tell them 8.0. But let's just give them 7.98 kilometers. All right? Let's just give them that. 7.98. Did they tell us how accurate they want it? No. So we're going to give it to them this way. So I'm going to just move this down. Down here. And that is it. And then put this on the diagram so we see what it helps you, right? Put this on the diagram. 7.98. Put on the diagram. So this side is now equal to 7.98 kilometers. That side. Then now, because we have this angle and this side opposite each other, we want to find any of these other two angles. Because the only thing we don't know in this triangle now are these two angles. If we want to find any of them, we can use sine rule. Because we have this pair of angle and side opposite each other. So sine rule now will give us any one of those two angles. So I'm certain we're going to need to find them. That's how these questions always go. It says calculate the bearing of S from Q. So let's make sure we get it right. So on the bearing in the direction from Q to S. Q to S. So you're going to draw this on the diagram properly. And make sure you're giving them the right angle, right bearing angle. Q to S. So Q down to S, we want the bearing. Q to S, let's make sure. Yes, Q to S, we want. So we want the bearing of this direction down here. So this is the front position. So we're going to put a north line up here. Let's put a north line up here like this. And show the bearing angle that we want is this angle clockwise down to here. I want to call it theta. And as always, because you want the bearing from this point, 90% of the time, the angle inside the triangle at this point, let's call it alpha, will play a part in the calculation. That angle will 95% of the time or more play a part in the calculation. So realize now to find the angle theta, it's gonna be theta is gonna be this angle to here, so plus the alpha. But I can say that the theta that we want is gonna be this angle in here plus the alpha. So theta plus alpha give us the theta. Right? This angle plus the alpha give us the theta. So how do we find this angle? Remember, that angle is co-interior with this angle. So these two angles add up to 180 degrees. We can find this angle easily. We can find that angle easily because we have almost the full angle around is 360, but it stopped at 311. So the angle inside here is 360 minus 311. But the total angle around would have been 360. And we have 311 there. So this angle inside here becomes 360 minus 311 is the one. 360 degrees minus 311. What is that? 49 degrees. That's how we get 49 degrees that we have here. And then now, this angle up here is now 180 minus the 49. But I agree with that? Because as I said, these two angles, they are supplementary. So this angle inside here is 180 degrees minus 49 degrees. How much is that? How much? What? 131 degrees. What good with that so far? And then the red angle now is the sum of the 131 and the alpha. So we're going to have to find the alpha anyway, right? I'm going to use sine rule for the alpha now. All right? So to find the alpha, I'm going to use sine rule right here in this triangle. Let's work it out right here and then we'll copy it down. So I'm going to use sine rule for the alpha. Sine rule for the alpha. So working in this triangle. So we're going to sine of alpha over the side opposite, which is the 3.5. Sine of alpha over 3.5 equals sine of angle that we know. The angle that we know is 126 over the side opposite to it, which is that 7.98. Then to find the alpha, we're going to multiply the 3.5 first, and then we're going to take the inverse sine. So first we're going to get sine of alpha equals 3.5 and the sine of 126 degrees over 7.98. That's what we multiply the 3.5 up here. That's what we get. And then now to get the alpha, we're going to have to take the inverse sine. The inverse sine come in front here. So alpha becomes sine to the -1 of everything here, which is the 3.5 sine 126 degrees divided by the 7.98. And we're doing that calculation. Let's put this in the calculator and we'll get alpha now. All right, let's just put this in the calculator and we'll get alpha. So it becomes sine to the -1 of a fraction. On top of that fraction is 3.5 times sine of 126. And we're dividing that by 7.98. That becomes 20.8 degrees is the alpha. All right, and then we can capture the theta now. Remember now, the theta is now going to be 131 plus the alpha. 131 plus the alpha. And I'm leaving all these calculations on the screen on the diagram. So see where I got these figures. All right, so they didn't jump out of the sky. Can leave this on the paper. All right, so let me copy this down and put this on the next page. We're going to need it, this calculation right here. All right. That's the alpha. So back to it now. We are saying that this angle that we want is theta. It's in purple. This angle that we want is theta. Outside the theta will be 131 degrees plus the alpha based on the diagram, right? That being angle theta up here, in the red, becomes the 131 that we worked out here plus the alpha inside here. I worked out that the alpha is 20 point something down here. So I'm going to use this angle down here, back up there now in the calculation, and let's work it out. Right? So that theta becomes 131 degrees plus 20.8 degrees. Okay, let's use 21. What does work out to? 151.8 degrees, right? Which you're going to put 152 degrees as the answer. You must always give bearings to 3 digits. That is the answer right here. But all right, that good. I advise you to go and read all these questions. Watch over the video. Do them over by yourself. Let's continue. Next one. Matrices. This question gives us the matrix W. The question says that to determine the 2x2 matrix L such that W plus L is equal to, that's called a null matrix or the zero matrix. So if you add two values and everything come out to be zero, it means that you're adding the addition inverse. So it means that, for example, to this 3, you added -3, don't you? And to this 6, you added -6, don't you? And to this -2, you added 2. And to this 5, you added -5. That's why the result is 0. But I can appreciate that. Good? It's not really no calculation. That's why they give 1 mark for it. I don't need no calculation, right? So we can say something like this. If W plus L equals 0, 0, 0, then the L equals 0, 0, 0, 0 minus the W. And the W is this. 3, 6, minus 2, 5. So that is negating every value here. So this 0, 0, 0 is immaterial. So the L becomes equal to negative 3, negative 6, 2, and negative 5. That becomes the L. Easy like that. But after that, is the 1 mark, right? Watch this one now. Then we can see this one now. Determine the matrix P such that W times P is equal to that matrix. What matrix is this? What matrix is that? 1, 0, 0, 1 is what? That's the I matrix. It means that these two matrices are inverse of each other. See that? It means that P is the inverse of W. Now we multiply a matrix and its inverse, you get the I matrix. See that? Don't it? So it means that the P, the P has to be the inverse of W. Because here, W times W to the minus 1 will be equal to I. That's a fact. So it means that this P has to be W to the minus 1. See it? So you calculate W to the minus 1, you find P. So you can say, therefore, the P that you want is W to the minus 1. Because if the product of them equal the identity matrix, then P is the inverse of W. So when you calculate the inverse of W, you find P. What is W again? Let's write it out here so it's on the screen. W is 3, 6, 3, 6, minus 2, 5. That's what W is. Shift it down a bit. I put it over here. So. That's what W is. I know calculate the inverse of that W. I want the inverse of this W. So write it properly. All right, so calculate the inverse. Remember, the inverse is what? 1 over the determinant times the adjoint. We calculate the inverse of W. That's what P is. So it's 1 over the determinant of the W times the adjoint of the W. So P equals 1 over the determinant. What's the determinant? It's this product, which is 3 times 5 is 15, minus this product, which is 6 times negative 2 is negative 12. So you're subtracting a negative 12. You have to be careful now. This minus minus becomes a plus. That minus minus becomes a plus. So this under here actually works out to be 27. Right? And they're multiplying that now by the adjoint of W. We do the adjoint again. Interchange these two values on the first diagonal. Interchange them. So the 5 goes there and the 3 goes there. They leave these two where they are. Don't interchange them. Leave them where they are and change the sign. So you change the sign of this 6 to negative 6. Change the sign of this negative 2 to 2. So the final answer now is divide each of these values by the 27. And leave that as the answer. Make this a little smaller. So it's fit. So the P becomes 5 over 27, negative 6 over 27, 2 over 27, and 3 over 27. What these values can be simplified. This can stay. There's no common factor there. But this can be divided by 3 and 3, right? So become negative 2 over 9. I divide it by 3, I divide that by 3. This one stays 2 over 25, no common factor there. And this one can divide by 3 again, 3 and 3, get 1 over 9. That is the answer. Let's get into the habit of simplifying your values when you can. You're expected to write your answer in simple form, simplest form. 1 over 9. But good? So we discussed that it was the ability to recognize that these two must be inverses of each other, because them equal to the identity matrix. Right? That is it. Next question. It's actually the transformation. So I write on a triangle, this is transformed by this matrix. All right. This matrix is reflecting in the line y equals x, and it reverses the coordinates. That's what it does. So I know we didn't do this today, but this matrix is reflecting in the y-axis, in the line y equals x. Reflection in the line y equals x. And reflecting line y equals x, the coordinates of points are reversed. So a point xy under the matrix n will be reversed to yx. That's all that happens when reflecting line y equals x. Coordinates reverse. And so x 1, 1 would map onto x prime, still 1, 1. If I reverse 1, 1, I can still get 1, 1. Then y, which is 3, 1. Y, which is 3, 1, under that transformation, n is going to y prime 1, 3. And then z, which is 3, 4, under transformation n is going to go on to z prime, which is 4, 3. These are the coordinates of m prime. Remember, I said that the triangle is m, and I want the image triangle m prime. So these are the coordinates of triangle m prime, these three. All right, so we didn't do that today, but that is that one. You can't fast. That's triangle m prime, coordinates of triangle m prime is. All right, but that's what reflection line y equals x does. Versus the coordinates. More things you know, the better, guys. Just an easy when you know the stuff. You have to learn what you need to learn. That's why I give you all those matrices to learn in the program. All right, this is our vectors question. This question says, diagram below shows triangle OPQ in which OP is 3U. And as you read up here now, you're checking the diagram if what they put up here is on the diagram. So OP is 3U. See here, OP is 3U, and I break it down for you. Break it down into 2U and U. So they're helping you. Good. Then it says, OQ is V. This is V. And that's on the diagram as well. All right? Because vectors in there. You want to see all the direction and path on the diagram so you can see how you get yourself around the diagram. It says Q is the midpoint of OQOR. So Q is the midpoint of this line. So let's populate the diagram with that information. You said this length and this length is the same. These two lengths are the same. And they are the same direction. And so they are equal vectors. So it means that the vector out here from Q to R is also V. Then put those on in the red. Let's put on the additional information in the red. So the vector out here is also V. Same direction, same length. That vector is also V out there, same as this. All right, what else? They said L is the midpoint. Oh, L is a point on OP such that OL is 2/3 of OP. So OL is 2/3, which is correct. Because remember, the whole thing was 3U, and this is now 2/3 of 3U is 2U. And so this part is also U. So this information, they have actually divided up the diagram, the line for us already, so we don't have to do anything from that information. So this information is already shown on the diagram for us. It says, write in terms of the U and the V, meaning that all the answers must have the U and the V in it. The vector LM. That's L to M. If you notice, we're gonna have to figure out over from L to M. All right? Did it tell us about M? Right, I said M is the midpoint of PQ. So M is the halfway mark down here. So all right, so we go from L to M. What we're saying we're gonna do, we're gonna come up to P first and then go down to M. And the M, the PM right here is gonna be half of the PQ. So it kind of makes sense to work out what PQ is first. You didn't ask for it. kind of makes sense to work out PQ. So let's work out PQ over here. Okay, work out PQ easy because we have two position vectors, right? So PQ easy. So PQ based on this diagram, PQ, show it out over here. Vector PQ is simply OQ minus OP. Because we have the two of them. So the OQ is V and the OP is 3U. That's what PQ is. And then this now is just half of PQ. So we can work it out there. So see, you know, LM, to go from L to M is the same as, that's what equal means, it's the same as. Go from L to P first, we're going to go from L to P first. And then, the plus means and then, we're going to go from P to M. P to M. That's how we're going to go from the L to the M. But the PM is half of PQ, which you know that the PQ is this. So this becomes LP, L to P plus half of PQ. So it becomes now, the LP is just U right here, U. Plus half of PQ is half of this thing. So we're gonna be half in the V and half the minus 3U. So it becomes half of V, and half of minus 3U is minus 3 over 2U. And then we are expected to consolidate these two values. That's the only V term in there, so we can write that back first. That's a half of V. And then now, it's like a whole minus 1.5. Like a 1 minus 1.5 is negative 1.5. Or, if you like, you can turn this into a fraction with the same denominator as this by putting it as 2 over 2. So like 2 minus 3 is negative 1. It becomes negative 1 over 2U. So you can do that as well. So it becomes minus 1 over 2U. That is what LM is. LM is equal to this. That's the answer for LM. Half V minus half U. Right? Half V minus half U is the answer for that. Next question says, what to find PR. Let's look at the diagram over from P to R. So R is all the way over here and P is up here. Okay, that kind of easy. When I come down here, so which is minus 3U, and then got 2V across here. So it's minus 3U plus 2V. See that? But I can see that, right? Diagram shows that. So it's minus 3U plus 2V. That's over from P to R. See it here to go from P to R, you're gonna go P to O. How can use position vectors, you know? Because we know the position vector of the R and the P. But the OP, we know it's 3U, and the OR, we know it's 2V. See there? The OR is 2V, and the OP is 3U. So we can use O time the last minus O time the first. So the PR then, using O time the last minus O time the first, becomes OR, that's O time the last, minus OP, O time the first. So it becomes OR, which is 2V, minus OP, which is 3U. So that is it. All right? Using last minus first. That's what PR becomes. Next part now, so must prove that L, M, and R are polynomials. So to do that again, we need two vectors with the L, M, and the R. Look if you have any yet, and they might have to find another one. So look at the two vectors with the L, M, and R. You can't use this. Because that have a P in it. There's no P down here. So you cannot use that. But for two vectors with these 2 points or one, and then you have to find another one, right? So we can use LM. We have LM that we can use. So we can use LM. Let's copy this down. We can use this one, LM. Let's copy that down. We're going to use LM. LM. Let's put it here. We're going to use. And we need another one. That's small. Using LM and so we need another vector now. LM and R. So we need something with R now. Huh? Can't use PR. You have to use two vectors with these 3 points. Cannot introduce any other point. Two vectors with those 3 points, L, M, and R. So it's either LR or MR we have to use now. We have a vector with these 2 points already. We need another vector either with the M to the R or the L to the R. One of them. You have to look at the diagram and see which one is easier to find. Right? See it here. These are the points showing that it's calling here. See them here? These 3 points. L, M, and R are calling here. It's not drawn to scale, but that's what it is. Right? These 3 points are calling here. Right? And I straight them. But the diagram is not drawn to scale, so that's why it looks like that. But that's what's supposed to happen. Those 3 points are calling here. So is that we're going to use LR or we're going to use MR? Which one is easier to find? Look at the diagram, quick. Which one is easier to find? LR or MR? Huh? LR. So you can see how you go from L to R. You're going to come down minus 2U and then go across 2V. See that? See it? Minus 2U plus 2V. Obvious, right? You don't have to calculate nothing. So we're going to use LR. So we're going to use LR, which is minus 2U, then plus 2V out here, so plus 2V. You can turn it around and write as 2V minus, I could use O time last minus O time the first two, you know, for this one, you know. I have the portion vector of the L and the portion vector of the R, so I could use that as well. But, so that's it, right? Same thing, minus 2U, minus 2U. That's what LR is. So that's what I want to use, this one. LR is that. All right, look at this one. This kind of easy to work with, you know. So I want to show that these two vectors parallel. You want to bring them to a state where you can equate them. So you want to get rid of the fraction out of that, and you want to make it become equal to that. But these are easy numbers to work with. If I multiply this by 4, it's going to become equal to that. I want to bring the vectors to a point where you can equate them. So if I multiply this by 4, this one, by 4 is going to become equal to that. So I'm not going to multiply by 4 straight, but I multiply by 2 and then multiply by 2 again. If I multiply this one by a 4, it's going to become equal to this one, which you can see. Multiply this side by 4, it becomes 4LM. Equal, multiply this by 4, it becomes 2V. Multiply it by 4, it becomes minus 2U. See, this and this are the same. So we're at the point where we can equate. It's going to equate next. So we're going to equate these two. Equate. So equate this to this. The two of them equal the same thing. So we can write that LR is equal to 4LM. See there, LR is 4LM. And with this, you're going to write out the conditions for collinearity with the examiner say. Because 1 equals the multiple of the next, the first condition you need for collinearity, parallel vectors. So LR is parallel to LN. That's the first thing you must have. The second thing you must have for collinear points, it's a common point. Clearly, L is a common point. See there? L is a common point. Clearly, L is on both vectors, so L is a common point. So that's the second condition for collinearity. L is a common point. When you have parallel vectors of common points, you can make the conclusion that the points involved are collinear. So you can say, therefore, L, M, and R are indeed collinear. And that completes your proof. That's how you prove collinearity. Get parallel vectors with a common point. That is it. I think this question finished. Want another break? I'm gonna put up question on the put up a question on the board. Maybe a couple of minutes to do it. Screenshot it and do it. I have to turn off this thing. I have to charge at the tablet a little bit because it's down to 17%. All right. So I'm gonna put up one on the board and you guys do it. I look at June 2021. Let's see which one was paid for money. Let's try this one. 2024. You see it today? So you do today. So complete, let me see. So you do a mock exam today. Complete it, let me see. More math equals better math. Let's go. Let me see. Let's see. Let's see what's on this paper. All right, circuit theory. So I'm gonna screenshot this one for me. So I'm gonna find all those angles. I'm gonna state the theorem why. State why angle B is 62 degrees. See the diagram there. State why angle B is 62 degrees. That's first question. State why angle B is 62 degrees. Let me see the next question. And then state why angle C is 124 degrees. State why angle C is 124 degrees. Angle C is 124. That's the first two questions. Then why angle OVW is 90 degrees. Why angle OVW is 90 degrees. Do those things for me. State why those angles. All right, angle OVW is 90 degrees. Then it says find the value of angle AD and E. Show all working. Then find angle AD and E. All right, after that, you find angle AD and E. So after I show these angles, I'm gonna find angle AD and E. All right, that's it. I'm gonna find angle AD and E. See here, angle AD and E. Show working. So this one I'm not asking for a reason. Just asking to show working and find the angles. That's that question. All right, AD and E. Give me a couple minutes of this. Then for this question, but this is a sine rule and cosine rule. This is not bearings. Diagram below shows quadrilateral PQR formed by joining those triangles. Calculate the length of QR is right here. That's just cosine rule to find this length. QR. Then, or they said the bearing of P from S is 205 degrees. Find the bearing of R from S. Screenshot it. Screenshot it. Screenshot this. Gonna find these two things. Let me see what they're gonna find. Those two things. The bearing of P from S is 205 degrees. Gonna find the bearing of R from S and the bearing of S from P. Go back up to the diagram. So you have the diagram. See the diagram here. Give me a couple minutes to do this one. All right. Boom. Next question. I'm gonna half an hour. Determine the matrix. The determinant of this matrix is 24. Find the value of V. Find the value of V. Then this is a different question. It says matrix L and M are defined as those. So find the matrix product LM. So you're gonna multiply those two matrices. And then find the inverse of L. Find the inverse of L. And then it says the vectors now says PQ is that. P is the point minus 2, 3. Determine the coordinates of Q. Determine the coordinates of Q. What else? Then I give you this vector diagram. This is a question I did today, some of you. I give you that information. And then they must find the vector AD down here. So first, screenshot it. And then find the vector BC. Find the vector AD and BC. And then this one. See the conclusion about AD and BC. that can be drawn from the responses in part 1 and part 2. All right, I'm giving you half an hour to do that. What time is it now? We finish at 9 o'clock. I'm giving you half an hour. I'm going to take the last part of the class and think there. Half an hour to do them 3 questions there. All right, I'm put up the clock, half an hour to do them 3 questions there that I just give you. The last 3 questions on the 2024 paper. Huh? Send the paper in the group. I'm sending the paper in the group. I send the group. I sent it today. It's in there. It's the June 2024 paper. Sent it today. So go ahead. So I put up the clock. And you do it. I'm going to turn this off. That's why I make it at the pictures. $30. 7 minutes. But come 2 minutes left. My attitude is being honest. Close the door, close the door. All right, so we're gonna throw these out. I will call it a day, all right? So might do another thing next week. So again, you can tell me the topics that you want me to go through next week. I can do another session like this next week, all right? Somebody said, linear programming. About linear programming, a certain to come an example. I like to do the topics a certain to come. Say the topic that we did today, certain topics that most company people are more certain. The bearings are more certain. The matrices is certain. The vectors certain. Circuit theory are more certain. Those questions almost certain to the people. You get me? So that's a good thing about these topics that we did today. All right, so we'll just go through these questions and then we'll just call it a evening. Right? We're gonna finish before 9 o'clock. That's all right. Can you lazy? Can you lazy? You're tired. Yeah, you've been here from 8:45. So I understand. Sorry. All right. And plus somebody have class tomorrow, 11 o'clock. So you know it is. All right, that's it. All right. Let me connect this back. All right, we're starting again, guys. They're behind by a couple. Hold on. They're behind by a couple seconds. Like, let's go. Stop. Stop share and start again. Staying up here. Stop share. Start again. All right, ready. I think we're gonna do this question again on Monday, but no problem. More maths equal better maths. We're gonna do this question again on Monday. Because this is the paper I gave you today. All right. All right, this is it. Question says, V, X, Y, and Z lie on the circumference of a circle shown below. Center O with a diameter VY. So that's a diameter. And my diameter subtends 90 degrees. It says UW, that's a tangent across here. It's a tangent at the point V. So you're thinking about tangent and chord. Angle between tangent and chord right here equals angle subtended by the chord. And then you have tangent and radius is 90 degrees. Also over this side, tangent and radius is 90 degrees. This part of that 90 degrees is 18. So this would be 90 minus 18 in case you need it, which is now this tangent which is now this tangent and chord. All right, but let's go through and answer the questions. It says angle VXC is 62 degrees, that's right here. And angle XVY is 18 degrees inside here. All right. It says, state a theorem that justifies the value of each of the following angles. So basically it's a rule, one of the rules. Why is angle B 62 degrees? Angle B is 62 degrees. Where is that? So angle B right here is already. Angle B up here is equal to the 62 degrees over here. Why is that? Because both of them are subtended by this chord. See, if you come back along the lines making the angle till you reach the circumference, then you'll find that that angle up there is subtended by this chord. I'm marking out in blue. That same chord is also subtending the 62 degrees up here at the circumference. And so that is the same segment rule. Both angles are subtended by that chord. And so that is 62 degrees. That's the same segment rule. Angles in the same segment are equal. Angles in the same segment are equal. When subtended by the same chord or arc. Now, if you stop right here, angles in the same segment are equal. Right here, I think 6 will give it a mark. Because the angles in the same segment are equal. They'll give it a 1 mark. That's what they're looking for, same segment. All right. All right. So the next one is angle. That angle is 124. So let me take this out. So the angle up here is 62 degrees. Let's put on the diagram. So this angle up here is 62 degrees. And the next angle that I must show is that angle C is 124. Now where is that? Angle C. Where is that? Angle C is 124. That's the angle at the center. That angle at the center is subtended if you come back along the sides until you reach the circumference. It is subtended by the same chord right here. Or it could be this arc. When you have a chord, let's work with a chord. The same chord is subtending 62 degrees at the circumference. One at the center is twice one at the circumference. That's a center rule. Angle at center is twice the angle at circumference. So that angle C is 2 times 62 degrees. So I want to say this 122 is 2 times. It is i.e. 2 times 62 degrees. All right, that is it. Because angle at center is twice angle at circumference. Right, that I get the money. Angle at center is twice angle at circumference. That's why it is 124 degrees. Let's put on the diagram again. So everything you find, you put on the diagram. Just in case you need to use it. So this angle is 124 degrees. Right here. 124 degrees. All right. Which angle do I want? Why is angle OVW at 90 degrees? OVW, where is that? OVW. OVW. That's tangent and radius. Angle between a tangent and a radius is 90 degrees. All right? Tangent and radius. That's 90 degrees down here. OVW. OVW is 90 degrees. Angle between a tangent and a radius is 90 degrees. That's the reason. That's because angle between tangent and radius is 90 degrees. That's the angle between a tangent and a radius. Next one now says, find these angles. I must show working where appropriate. First, I want angle A. Let's look at the diagram for angle A. Angle A, where is it? Angle A over here. So angle A, angle A is the angle between, angle A right now is the angle between this tangent and this chord. So the angle between a tangent and a chord is going to be equal to the angle subtended by the chord up there, the circumference. So angle A is equal to 62 degrees up here as well, because the chord subtends 62 degrees. So this angle out here is 62 degrees. So let's put that. So this angle out here is 62 degrees. Angle between tangent and chord equals angle subtended by the chord. That's right. Angle between tangent and chord equals angle subtended by the chord. So this angle is 62 degrees, because angle between tangent and chord equals angle subtended by the chord. That is it. Angle between tangent and chord equals angle subtended by the chord. All right. Next angle I want is angle D. Let's see what angle D is on the diagram. D. That's this angle in here. Now angle D is one of the angles in this triangles, and the isosceles triangle. Remember, the second triangle is always an isosceles triangle. All right. So these two angles equal, marking out in red. These two angles equal, because these two sides equal. That's a radius and that's a radius. So that's an isosceles triangle. So that angle then is equal to this one over. This one over is also D. So D is 180 minus the 124 divided by 2. But the total angle in the triangle is 180, and these two angles equal. So it's 180 minus the 124 divided by 2. All right, so let's do that. So D becomes equal to 180 degrees minus the 124 degrees divided by 2. What that work out to? Minus 100 minus 20, that's 54 divided by 2, right? 28 degrees. 28 degrees, good. That's because total angle in the isosceles triangle is 180 degrees. So the fact that it's isosceles, that's why we divide by the 2. All right? That's 2 equal angles it has. So that is it. So that angle is 28 degrees. Let's put on the diagram, 28 degrees. So put them on the diagram as you find them. So these two angles are 28 degrees. So this is 28 degrees. And this is 28 degrees as well. All right. And good. For these two are up to 90, which is good. All right, let's continue. Which angle we want again? Angle E next. Angle E. Angle E. Here is it. Angle E over here. Can get that one now. Angle E. All right. So angle E. We can basically work this big triangle right here to find angle E. Can work in this big triangle to find angle E. Not one way to do it now, but can work in that big triangle since you know this angle down here is 62, and we also know this angle over here is 18 plus 28, and then we can work out that one to find the E. Those three angles must add up to 180. All right, those three angles must add up to 180. I'm not seeing another way right now to do it. That's sure there are other ways to do it, but that's the method I'm seeing right now. That's the method I'm seeing right now. I'll take another look. See if I see another way. Da, 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 da. All right, that's what I'm going to use. That's what I'm going to use. Could have also done this. Could have do as well. Could have find this angle over here, so angle between this tangent and this chord, and that angle out there, this angle subtended by this chord up here is equal to this angle. Could have done it that way as well. So these two angles equal. And the angle inside here is 90 minus 18. And then the total angle up here equal at 90 minus 18. So we could have done that as well. Those two angles are the same. Right? Those two angles are the same. So we can set up like this. This angle down here first is 90 degrees minus 18 degrees. How much is that? What is that? 72. So this angle up here is also 72. So based on that, we could solve over here now. The total of the E and the 28 is 72. So we could say E plus 28 is 72. Right? E plus 28 is 72. But the angle between the tangent and the chord equals the angle subtended by the chord. But everybody understand that? I'm showing you? Good. So the 72 over here, 72 over here, this angle is also 72. So add them up and add them up to 72. So to get the E becomes 72 degrees minus 28 degrees. How much is that? Huh? 44 degrees. So that's the method we can use. As I said, we could use the total angle in this triangle as well. Try that way, you're gonna get the same answer. All right. So that is it. So I'm gonna write it down here. That E equals 72 minus 28. E equals 72 degrees minus 28 degrees, which is 4 degrees. Right? And you use the fact that angle between tangent and chord equals angle subtended by the chord. All right, so we're saying, it's basically saying this angle between the tangent and the chord equal angle subtended by the chord. So that's why these two angles add up to 72 degrees. And then we have to write this up for this as well. That's angle between tangent and radius, 90 degrees. So this angle is 72 because it is 90 minus the 18, because the whole of this angle here so is 90 degrees. So you could write that angle between tangent and radius is 90 degrees. That's how we subtract 90. We do 90 minus the 80. All right, but this tangent and chord, this tangent and radius, angle between them is 90 degrees. That's it. All right, let's finish that question. Did down here now. Says the diagram below shows a quadrilateral PQRS formed by joining two triangles, PQS and QRS. So these two triangles, none of them are right angles. So we have to use sine rule and cosine rule in them. Can I use so-called tower? Can I use Pythagoras theorem? So-called tower and Pythagoras theorem are left only for right angled triangles. All right. First one we have to find is the side QR, which is over here. So we're going to use cosine rule in that triangle because we have two sides and angle between. So we're going to use cosine rule. Cosine rule. Cosine rule starts out like Pythagoras theorem. Remember, treat it like it was an hypotenuse and this as if that was a 90. So it is that QR squared, if it was an hypotenuse, would be equal to this side squared plus that side squared. That's 18 squared plus 16 squared. But it's not a right angle triangle, so you have to subtract a piece. You subtract 2 times the 18 times the 16 times the cosine of the angle between them. Angle between them is 25 degrees. Youngster, pay attention now. Then instead of squaring here, we can square with both sides, cut out that square and square with that side instead. And then just do one calculation. Oh, that is the clock. Sorry about that. I need a clock. I'm doing this calculation. So square root of 18 squared plus 16 squared minus 2 times the 18 times 16 times the cosine of the angle between them, which is 25 degrees. That's 7. QR becomes 7.61. That is meters. Units are meters. 7.61 meters. Put on the diagram in case we need it. 7.61 meters. That's that side here. Next part now says. Next part says the bearing of P from S is giving us P from S. Always note the from position. So it's from S to P. The bearing is 205 degrees. Let's put on the diagram so we can see how we use it. See what is it again? S to P. S to P. S down to P is 205 degrees. So I'm going to show that angle on the diagram. Let's put in the north line here. And then the bearing that they just gave us 205 degrees all the way around here. It's 205 degrees. And this part of it add up to what? What is that? 97. So the remaining angle in here must be 205 minus 97. This angle inside here has to be 205 minus 7. It's actually bearing down to R from S. All right? That angle there. All right? Let's see what they want us to find though. They want us to find the bearing from S to R. Same thing. From S to R. It's that blue angle in the diagram that was marked. See? From S down to R. It's this blue angle inside here. Which becomes the 205 minus these two. Alright? The whole thing is 205 and these two add up to 97. So the bearing that we want right here comes 205 minus those two. Let me write it out here. 205 degrees minus the sum of those two. The 25 and the 72. That's what we're working out. This thing. So this is equal to this. What are we working out to? Huh? 108? 108 degrees. That's the answer. Next part wants the bearing from P to S. So let's note it's from P to S. You want the bearing in the direction PS. PS. Let's see where that is now. T up to S, we want the bearing. All right, I'm sure a nice way to find the bearing of PS now. Because you have all angles you need, you know. So you want the bearing from P to S, right? So basically, pay attention now, guys. You don't have to actually work it out down here. You know. The bearing from P to S, if you put a north line down here, to be this angle. Because the bearing of this direction, P to S, this way. Because we have all these angles in this area. Okay, I worked out in this area as well. By doing what? Extending the direction of the line. All right, so we come up here. This is the direction of P to S, same way. This direction is still P to S, like this. This direction, this line. If I extend this line, that's still the direction P to S. So I still want to bring up that direction. Let me extend this north line for you. So we can show you. So this is the north line that we have. So the bearing angle that we want from P to S is actually this angle. Right here, so. The same direction. See that? What I can see that? The same direction. See, if I put a north line here, this angle, the same angle disappears, so same angle, corresponding angles. Bearing is the angle of a direction. The direction from here to here is the same direction up here, so it's the same direction. And the bearing of that direction, working up there, we have all those angles, which is easier to work with all the angles up here, is this. So it becomes, the whole of this around here, so it's 205. From here to here to that straight line. From here to here to that straight line, 180. So to get the angle in here that you want, it's going to be 205 minus 180. See? What you can see that? 205 minus 180, right? Because the whole thing around here is 205. But on this purple line from here to here is 180 degrees. 180 degrees. So the bearing inside here so that you want becomes 205 minus 180. Yeah? That is the bearing. So it's easier to work it out at that point we have all those angles. So this angle inside here that we want, the bearing angle that we want inside here, use the purple for it. That bearing angle that we want becomes 205 degrees minus 180 degrees. What I work out to? How much? 25? But because this bearing, I'll put the 0 in front of it, right? Good. So you see, it's easier than to come down here and work. Because to come down here and work, you have to work out down over here. So first, by doing 360 minus the 205, and then the 180 minus that to get this one done. So we're going to come to the same thing, right? So it's easier to just work it out. Up there, we have all those angles around the place. So it becomes 25 degrees. So the bearing is 0, 25 degrees. So which means 205 minus 180. So this becomes equal to 205 degrees minus 180 degrees, which is 25 degrees. We'll put a 0 in front of it for bearing. That is the answer. Nice and easy. Much more to give 2 marks for that. Very good. Our question done. All right, one more. So this one we're actually finish the time. So we're actually going to finish at 9 o'clock for you. All right. So the question gives us this matrix. And they tell us that the determinant is 24. Must find the values of V. See, the determinant of the matrix is 24. The determinant equals 24. What's the determinant? Get an expression by the determinant and put equal 24. The determinant is this product, which is 6 times negative V, which is negative 6V, minus this product, which is 2V times negative 5, that's negative 10V, minus 10V. But understand that? But understand that? This is the first diagonal product, minus 6v. And you subtract the second diagonal product, which is this, minus 10v, because it's 2v times negative 5 is negative 10v. This minus minus becomes a plus. That's all equal to 24. So this is minus 6v plus 10v equals 24. If you want to work it out. 10v minus 6v is 4v. So 4v equals 24. They divide by 4. You divide by 4, 24 divided by 4 is 6. So v equals 6. That is the answer, right? But understand that? Divide by 6. No, divide by 4. But go to that? Yeah? So just set out the expression for the determinant and put it equal to 24 and solve. That's all. Don't even know. It says L and M are defined by these two matrices that are 2 by 2, that are 2 by 1, a column matrix that are 2 by 2. It says evaluate each of the fund. First, I want the product L times M. So multiplying this one times this one. Let's set it up. So it's 9, 5, 3, 2, multiplied by the one column, 2, negative 4. That's going to give you a column matrix with two values, one here and one there. Or you multiply them again, same thing. The rows of the first matrix times the one column. So the first value here, first row, one column, is the product of this first row and this one column to get that first value up here. So it's first element times first element, second element times second element. So it's 9 times 2 is 18. And 5 times negative 4 is negative 20. Then the second value down here is position in the second row and the one column. So to get it, to multiply this second row by the one column. First element times first element, second element times second element. First element times first element, second element times second element. 3 times 2 and 2 times negative 4. 3 times 2 is 6. And the 2 times negative 4 is negative 8. Negative 8. And then just put the final value down here. So the 18 minus 20 is negative 2. And the 6 minus 8 is also negative 2. So you're supposed to get negative 2, negative 2. Shift these up a little bit. That's it. Negative 2, negative 2. All right. Next question. The inverse of L. Let's write down what L is again so in front of us. L is 9532. L is 99532. So the inverse of L, L to the minus 1 equals 1 over the determinant of L times the adjoint of L equals 1 over the determinant. What's the determinant? This first diagonal product, which is 9 times 2 is 18, minus this second diagonal product, which is 3 times 5 is 15. So the determinant under here is a 3. Then multiply that now by the adjoint matrix. Or you do the adjoint again. Interchange the elements on the first diagonal. Interchange them. So you get 2, 9. Leave the elements on the second diagonal where they are. Change the sign. So leave this where it is and change it to a negative 5. Leave this where it is and change it to a negative 3. And then divide each of these values by this 3 under here now. You get the final answer, which is equal to, this divided by 3 becomes 2 over 3. Negative 5 divided by 3 becomes negative 5 over 3. Negative 3 divided by 3 becomes negative 1. 9 divided by 3 is 3. So this is your final matrix down here, the inverse. That's your L to the minus 1. That is it. All right. Then them say a different question. The vector PQ is 5, negative 4. And the point P is negative 2, 3. And I want us to find the point Q. So what we can do, we can pull up this vector, split it up. split it into position vectors. I know we didn't talk about that today, but don't matter, I don't just need to see it one time. To find the coordinates of Q, we need to find the vector OQ first, because the vector OQ will have the same values as the coordinates of Q. So we're going to split up this vector into position vectors. So we're going to split up this side, the PQ, into O times the last minus O times the first. So it becomes OQ minus OP. That's what the left side becomes. And that becomes equal to the 5, negative 4. 5, negative 4. Then to leave OP as a subject, we can take to leave the OQ as a subject, we can take the OP and bring it over here and add it. So the OQ subject becomes 5, negative 4, plus, this goes over here, becomes a plus OP, plus the vector OP. We're going to give us the coordinates of P. If you know the coordinates of P, then it means that if P is a point, negative 2, 3, then OP vector will have the same value, negative 2, 3, in the column vector format. So this vector is negative 2, 3. Negative 2, 3 is the OP. So you can just write those out now and get the final value down here. So OQ, the vector OQ becomes 5 minus 2 is 3, and minus 4 plus 3 is negative 1. That's a position vector of Q, but the question asks us for coordinates. So we can write, therefore, coordinates are written like this, having the same values of this. If the position vectors have these values, the coordinates will have the same values written as a row, in a row form. It's coordinates, 3, negative 1. You cannot leave this as the answer. This is the answer down here. That's how coordinates are written. So to find the coordinates, find the position vector, because we're given vectors. Because position vectors and coordinates have the same values. All right, so I'd advise you to go on to this question over again. Kind of unique in a sense, this one. Easy, but kind of unique still. And that's not the only way to do it, but this is a good enough way to do it. All right, let's continue. Vectors again. It says, in the pentagon, OABCD, OA is parallel to BC. So these two lines, right? Which one I'm saying? These two lines parallel. So one is a multiple of the next, then parallel. And these two parallel as well. Right? AB is parallel to OD. And you can see that by putting in the double arrows on that means that those two parallel. Single arrows on these means that those two parallel. All right, then it says OD is 2 times AB. So this length is 2 times that length. All right, and I'm also parallel. And then OA is 2 times BC. So these two have that relationship as well. This is 2 times that. All right, and you can see that the OA is A right here, and the AB is B up here. So, all right. So if this is 2 times this, and this is a B, that means that the vector down here is 2B. So you can put that on down here. This vector down here is 2 times this one, 2B. And then now, if this is A, and it is 2 times this one, then this has to be half of A. See that? Half of this, because this is twice as long as this. So this has to be half of A. So if this is A, this has to be half of A. So this vector down here is half of A. Half A. All right? So ready to answer questions now. So you put on information on the diagram and you answer the questions. You want AD. So you can look at the diagram to see how we go from A to D. But because we have the two position vectors, see them here, we have the OA and the OD. We can use O times the last minus O times the first. So we can just use OD minus OA. All right? Because we have the OD vector is 2B and we have the OA vector. When you know the position vector, they can use that. O times the last minus O times the first. So it becomes 2B minus A. You could also look at the diagram and say, oh, you go from A to D, which is to come down here, which is a minus A, and then go across here, which is a 2B. minus A plus 2B. So you could have done it that way as well from the diagram. All right. Next part wants BC, the vector BC. Let's go to the diagram again. So we want to know this vector BC. So to get the vector BC, we can just go around the diagram here, so until we reach from B to C. Because we can't come across here because we don't know that. So we can come back here, come down here, go across here, and then go up here. I think maybe that's the easiest way to do it. All right, just go around from B to C until we reach it. Adding up all these vectors, add them up. And remember that if we're going to opposite direction is minus. So I'm going to do it right here on the screen and then we'll copy it down. So see it here now, to go from B to C. We're going to come right here, so first with a minus B. Minus B. We're going to come down here, so with a minus A. Minus A. We're going to come across here, so with a plus 2B, because going in the same direction now, so it's a plus 2B. Plus 2B. And then come up here, so now with a half A. Plus half of A. But understand that? Understand that? Good? All right. So let's add up the values now. The like terms. All right. So the B is 2B minus B. That's a B. And then you have half A minus a A. A half minus 1 is minus half. Right? So that becomes minus half A. And we can check if it's right by looking over from this to this. Look, this is saying to go from B to C, you must go a B first. What's a B? A B is the same length as this. All right? Let me show you. So this is saying go a B and then go minus half A. Let me show you. So this is a B. It's a half A now, one half of it. Or a half A. So see you know, if I copy this B across here, like so. Move this B across here. So that is a B. That's a B. And then move the minus half A up here. So that's a half A. Just have to go with minus half A. See it? That's a B. And that's a minus half A. It takes it from B to C. So you can accept the answer. But understand that? But that's good? So something you can check if your answer is correct by doing that, right? Look if the calculation and the diagram match, which they do. All right, so this answer is correct. Just copy this down and put where it's supposed to go. Right here. All right. What else am I to do? It says state the conclusion about the mod. This means the length. This means this is modulus. The length of AD and the length of BC. That can be drawn in response. This is one mod. Some parallel thing are the length them want. The length of the two lengths. What's the relationship of the two lengths? All right. So basically, you multiply this one by 2, becomes equal to that one. You can see it. All right, we'll put them down. So the AD, let's work out on the AD was 2B minus A, right? And the BC is the next one was a BC. The BC is B minus half A. B minus half A. So you're comparing these two vectors now. All right? So what I can do to get rid of the fraction, multiply this one by 2. Get rid of the fraction. So I multiply this one by 2. In vectors at this level now, they'll always test something about parallel vectors, polynomial points. So they might just ask the question in a different way, because that they're testing anyway. So multiply this by 2, you're going to see that the vectors parallel. So multiply this one by 2, multiply this by 2, you get 2BC. Multiply this by 2, you get 2B. Multiply this by 2, you get minus A. So let's say this and this equal. Because those two equal means that the AD equal minus 2B, minus equal 2BC. Right? So you can equate them now. Equate these two things. When you equate them, you're gonna see that AD equals 2BC. So that means that I'm parallel now. And this means that the length of AD is 2 times the length of BC. That also means that, which is what this is asking about, what's the relationship between them. Can you see it on the diagram? It's two sides, AD and BC. See here, AD is this line across here. It's 2 times this length, which is BC. And then parallel. So if you ask for two relationship between them, you can say that the parallel and AD is twice as long as BC. That's what it means. You can even see it on the diagram. And this is asking about length. I see them have modulus. That means length. The modulus, when I put the lines on the side of it, it means the length. They're talking about the length of the vectors. So to finish this, we can actually go down here and modulus the two sides. Because if AD equal to BC, then we can modulus both sides. The modulus of AD comes equal to the modulus of 2BC. And when you take the modulus, you can basically drop off the arrows. I can put this multiplier out here. So modulus of AD is equal to 2 times the modulus of BC. And this means that AD is twice the length of BC. And it is true in the calculation, it is true on the diagram. See there, AD is twice as long as BC. That's what I wanted. But could have also asked that the parallel, but they also parallel. But we got one other month for the next. All right, guys, that is it. Bye, everybody. Bye, online.
Bye, sir.
All right.
Bye, sir.
You can send the video. Oh, the video is on my channel. The video is gonna be on my channel, but I want to watch it over. The video is gonna be there on my channel. I can send me a WhatsApp. You can send me a WhatsApp and I send the link. Supplicate. Number is 881-5600. You can send me a WhatsApp here and I send you the link and maybe we send you the papers that we did today. Huh? The papers? Yeah, give me my card. Give me a second. All right, everybody, have a good night. I'm gonna end it now and I'll announce when we're doing another session, maybe next week. Huh? The notes them. You mean the questions? Oh, those notes. Send me a WhatsApp. Send me a WhatsApp. You need the those documents. Send me a WhatsApp. And I send it to you. All right, everybody. Bye. Have a good night.